what we will unpack at this conference.
Sorry.
But let us start where it all starts, the tools we use to build. Software engineering has always been about having the right tools to bring your ideas to life, continually perfect and craft and tame complexity.
Developers.
We're continually evolving these tools. We are seeing incredible momentum, adoption, and diffusion. In fact, Visual Studio family now has over 50 million users. GitHub has 150 million users. GitHub Copilot, in fact, has been used by more than 15 million developers, and we're just getting started.
That's a lot, but
we have a bunch of new
like
updates we are rolling out at Build, starting with Visual Studio. It is the most powerful IDE for .NET and C++, and we're making it even better, right? .NET 10 support, live preview at design time, improvements to Git tooling, a new debugger for cross-platform apps, and much, much more. And we're moving, by the way, to a monthly cadence for stable releases as well. And when it comes to VS Code, just a couple of weeks ago, we shipped our 100th release in the open. It included improved multi-window support and made it easier to view stage directly from within the editor. And GitHub continues to be the home for developers. GitHub Enterprise has tremendous momentum in the enterprise. And we're doubling down for developers building any application.
You pulled it together well.
Trust, security, compliance, auditability, data residency are even more critical today. Now, starting with tools you use to the infrastructure you deploy on to reach the users and the markets you want. Talking about trust, open source is at the core of GitHub, and we're taking this next big step. As GitHub Copilot has evolved inside VS Code, AI has become so central to how we code. And that's why we're open sourcing Copilot in VS Code. We're really excited about this.
Oh, wow. That's interesting.
This is a big deal. Starting today, we will integrate these AI-powered capabilities directly into the core of VS Code.
Copilot's just kind of a knockoff, in my opinion.
Bringing them into the same open source repo
that
powers the world's most loved
Cursor,
dev tool.
Windsurf, Cline,
and of course,
much better.
We'll continue to build out GitHub Copilot too. In fact, over the past few years, we've gone from code completions to chat to multi-file edits and now agents. And this same pattern is emerging more broadly across the agentic web. You can ask questions and AI assistants give us answers. You can assign tasks to agents and have them execute them, or work side by side with AI to complete jobs and projects. And you can mix and match all of these form factors, right? That's kind of what we care about as developers. It's not about any one of them. In fact, we're building app modernization right into agent mode, right? So Copilot now is capable of upgrading frameworks like a Java 8 to Java 21 or .NET 6 to .NET 9 and migrate any on-premise app to the cloud. It creates a plan for your code and dependencies, suggests the fixes along the way, learns from changes you make, and makes the entire process seamless. And the next thing we're introducing is an autonomous agent for site reliability engineering, or SRE. I mean, think about one of the biggest pain points for any of us, right? Getting woken up in the middle of the night to deal with a live site issue.
Yeah.
Take a pager duty, memory leak issue. The SRE agent starts automatically triaging, root causing, mitigating the issue, and then it logs the incident management report as a GitHub issue with all the repair items. And from there, you can even assign the repair items to GitHub Copilot. And we're not stopping there.
I see what
this is the next big step forward.
This is directly going against OpenAI's
coding agent built right into GitHub.
Convex?
Taking Copilot from being a pair programmer to a peer programmer. You can assign issues
this is directly
to Copilot,
at OpenAI.
bug fixes, new features, code maintenance, and it'll complete these tasks autonomously. And today, I'm super excited that it's now available to all of you.
All right. Codex, sorry, not Codex, OpenAI Codex.
Let me walk over. Gone are the days when I could just simply, report bugs. At this point, I'm assigned bugs to fix, and that's kind of called empowerment. And here I am with all the bugs that I have or issues that I have to deal with in GitHub issues. The first one is adding a filter for user group size, community page. Let's go take a look at this issue. It's nice. They say like I've got to go put some new filter up here. It also shows me where. I guess it needs to do a range, small, medium, large, by size, or some kind of a percentile. It's like some kind of a group by, case when type of thing. So anyway, so let's do the thing that is easiest for me. In fact, it even has some caching stuff, which I have no idea what that is. But I guess there's a staging cache and then a Redis. OK, fine. Let's do the thing that I can do, which is assign it to my new buddy, Copilot. So I'm going to assign it. And there you go. Let's go and see. Let me scroll down. It's picked it up. It sees me. It creates a PR. And you see that nice eye emoji? It sort of knows that I'm here, and it's sort of going on to work. And we'll come back and check it out later, right? It's just so fun, right?
The fact that this integrates with GitHub like this makes it really kind of one up on OpenAI.
But what it's doing is it's setting up a branch. It starts GitHub Actions in the sense it just generates the compute for you or creates a virtual machine using
that's
GitHub
exactly
Actions.
What
it commits a draft PR to session logs. And in fact, you can go back to the session logs and continue to see all the draft PRs as it's working. Our coding agent respects all the security measures while delivering a great developer experience. That's obviously super important. The agent works in its own branch. It only uses MCP servers configured by a developer. We can get other agents to do code reviews and keep people in the loop before they run any CI/CD or merge. And we're also making all these intrinsics available to partners to ensure that there is an open and secure ecosystem of agents, whether it's SRE, SWE, code review, and many, many more agents that all of you will build. And of course, we also want to ensure that individual developers, as well as IT, have all the controls here. And talking about ecosystem of agents, we're very excited about OpenAI's Codex agent that was just launched on Friday. And I'm thrilled to have Sam Altman join us virtually. Welcome, Sam, to Build.
Let's go.
Thank you. Thank you for having me.
Hey.
Bro, it looks like you just woke up.
Bro. One of the things I know you've thought a lot about, all these various form factors that developers use for software engineering. Of course, you did the CLI, and now, last week you did the coding agent.
He's like direct call out.
You want to talk a little bit, Sam, as sort of the vision you have for how software engineering evolves, and actually how developers will use all these various form factors together?
Yeah. So, Satya, you and I have been talking about this for a long time. In fact, the very first version of Codex, I think it was all the way back to 2021, one of the very first things we did together in GitHub. And we've been talking about how someday we'd get to like a real agentic coding experience, and it's kind of wild to me that it's finally here.
They both
I think this is one of the biggest changes to programming that I've ever seen. But this idea that you now have a real virtual teammate that you can assign work to, that you can say, hey, go off and do some of the stuff you were just doing, and increasingly more advanced things. At some point say like, I got a big idea, go off and work for a couple of days and do it. And that you can issue many requests in parallel, that you can be fixing bugs, implementing new features, answering questions about the code. This is like true software engineering task delegation. And I think it'll only get better from here, but this is just a tremendously exciting moment. It integrates very deeply with GitHub. You can give it access to a repo and an environment, and you can get some pretty amazing stuff done.
Yeah, no, it's really exciting to see that. And it's also sort of great to have developers stay in the flow, work with essentially peer programmers, these agents, as well as other people that we collaborate with, and just have the developer process itself and the life cycle get faster. Obviously, you also are working on a lot of models and are very sort of fantastic. In fact, we've had a chance to sort of sim ship a lot of the models you guys have built. Just tell us a little bit about what's sort of coming as far as the model roadmap itself.
The models are already very smart. They will continue to get smarter too. But I think one of the most exciting things is the models will get simpler to use. You won't have so many to pick from. It'll just sort of automatically do the right thing. They'll get much more reliable. You'll be able to trust them for much more. There'll be a lot more features like multimodality and great tool use and integration. It'll be closer to the it just works. I can talk to it. I can do a complicated coding agentic thing. I can rely on it. And I think people are going to be surprised at how fast we're going to make progress in those directions now.
Yeah, I know we're very excited about your
like
model roadmap. And obviously, when you look at ChatGPT, it's the most at-scale, stateful agentic app today that you guys built. And of course, Codex is another sort of agent app that you build. And this conference is all about unpacking so that every developer can, in some sense, build these new agentic apps, that use the model, do their own model scaffolding, go on to even do multi-agent orchestration and so on. Any advice you have as people build out these high-scale production, stateful agentic apps, Sam, based on obviously what you guys have been doing and leading?
I think one of the hardest, most difficult things to manage about this is just the rate of change. If you think about what was possible 2 years ago or 1 year ago or now, and what will be possible in another year or 2 years, sort of planning for this incredible increase in model power and how people are going to build products and software and companies in the kind of near future, and really leaning into the new tools and the sort of new workflows that are possible. Again, we haven't seen many technological shifts like this in history, but every time one has come, like leaning in early and hard has been very rewarded.
No, and that's absolutely well said, because at some level, one of the things we want to really unpack at this conference is what's that app server that allows you to take the latest new sample that
NVIDIA
comes and keep moving at that pace, because I think that's the challenge we have as developers building these applications.
Like, but
it's fantastic again. Go ahead.
Yeah, I was just going to say, it was amazing to watch over the last few months as we were working on Codex internally. There are always a few people that are the early adopters, and how quickly the people who were just using Codex all day changed their workflow, and just the incredible amount they were able to do relative to someone else was quite interesting.
No, it's fantastic. Thank you so much, Sam. Thanks for the partnership. See you again at Build Again.
He's like interrupts him. He's like, all right, you're gone, bro.
It's an incredible time to be a developer, and all these tools getting richer. And more importantly, it's not about any one tool, any one agent, or any one form factor. It's about the coming together of all of it for us as individuals and as teams of software engineers to be able to express our craft. Now, let's go up the stack. Let's talk about the platform opportunity of Microsoft 365.
All right.
I'm very excited about the latest update to Microsoft 365 Copilot, which is now generally available. It's really exciting to see this.
I've yet to use Copilot.
This is the biggest update. In fact, if you think about, I don't think since Teams launched, we've had an update of this level. And it really brings together chat, search, notebooks, create, and agents all into this one scaffolding that's intuitive.
That is cool that it is all this under a single.
This is the UI for AI. And chat, for example, is grounded both on web data as well as your work data. And that's the game changer, especially with Pages. Search works across all of your applications, right? Whether it's Confluence or Google Drive or Jira or ServiceNow, not just M365 data.
Don't talk about Jira.
With notebooks, I can now create these heterogeneous collections of data, right? In fact, I can have chats and pages and any documents, emails, all in that collection.
Interesting.
And then, in fact, I can get all these audio reviews or podcasts out of it.
It's like Google Gemini.
I can use Create, to turn a PowerPoint into a new explainer video or generate an image. And when it comes to agents, we have a couple of special agents, like Researcher, right? It's been perhaps the biggest game changer for me because it's synthesizing across both the web and enterprise sources, right? Applying deep chain of thought reasoning to any topic or any project. Analyst goes from raw data across multiple source files. I can just upload a bunch of Excel files. It will get the insights. It'll do forecasts. It'll do all the visualizations. And these agents are all at the end about putting expertise at your fingertips, right? Bill, a long time ago, had talked about information at your fingertips. I feel we are at that age where we are now going to put expertise at your fingertips. And Teams takes all that and makes it multiplayer, right? And all of the agents you build can now show up in Teams and in Copilot, and you can ask questions, assign action items, or kick off a workflow by just mentioning an agent in a chat or meeting. And with the Teams AI library, building multiplayer agents is easier than ever. It now supports MCP, and with just one line of code, you can even have it enable A2A. And you can add things like episodic or semantic memory by using Azure Search and a new retrieval system, which I'll talk about later. And as a developer, you can now publish. And this is the biggest thing. Right now, you can build an agent. You can publish your agent to the agent store and have them discovered and distributed across both Copilot and Teams, providing you access to the hundreds of millions of users and unlocking that opportunity.
Like, again, it's a platform
over the past year, we've seen so many partners across every industry build agents that connect to Copilot and Teams. And let me just share a few examples, right? With Workday's agent, you can ask Copilot what needs your attention. It gives you a summary of all the Workday tasks, so you stay on top of the learnings, the approvals, the workflows. ServiceNow agent, you can ask it in real time about an incident, all the resolution metrics, and then you can use it to instantly create a PowerPoint presentation with all the results contained. With LSEG agent, financial professionals can discover, analyze, share any financial data that the exchange puts out right in Excel and PowerPoint. And with Copilot Studio, you can start to build your own agents. We've shipped a ton of new features into Copilot Studio. Most recently, we put in a full QA agent right into Copilot Studio. MCP, agent flows, and this is very key. Right now, you can mix and match both LLMs and deterministic workflows. Today, we are making it easier to build even more complex multi-agent workflows in Copilot Studio using orchestration. Take something like onboarding a new hire. Right? It's actually a pretty complex process, actually. It involves agents from facilities, finance, legal, and each with their own expertise and workflows, right? And so you can bring them all together, and everything moves faster, and the experience is better for everyone. That multi-agent orchestration right in Copilot Studio. All up, you have built 1 million plus agents that connect with Copilot and Teams in the past year, and we're not slowing down. Today, we are introducing a new class of enterprise-grade agents you can build using models fine-tuned on your company's data, workflows, and style. We call it Copilot tuning.
Good clap.
This is a big deal. I mean, at some level, this is about
I was just gonna say, is this a big deal
using Copilot, but it's about tuning Copilot for every customer, every enterprise, every firm. Copilot can now learn your company's unique tone and language, and soon it'll even go further understanding all of the company's specific expertise and knowledge. All you need to do is seed the training environment with a small set of references and kick off a training run. The customized model inherits the permissions of all the source control, and once integrated into the agent, it can deploy to authorized users, right? So you can sort of go to groups that you've set up and distribute it across Copilot. For example, if you're a legal firm, it'll reason through past arguments and relevant literature and deliver answers or generate docs that are very specific to your firm. Or if you're a consulting company that works across, let's say, multiple vertical industries, you can now start to tune these models for each vertical industry to reflect sort of the specific know-how you know about the workflows in that industry.
I see how this could be useful.
It's all about taking that expertise.
But it's more so the execution. I've heard that a lot of the Copilot's execution are kind of botched, and so it's kind of like gimmicky, and I can see that.
And also your products and services reflect it. And to sort of give you a feel for all of what I've talked about, let me invite up on stage Midi to show you all of Copilot or ecosystem. Midi, over to you.
Yo, what's up?
We as developers can easily scale productivity solutions using the new Microsoft 365 Copilot app, Copilot Studio, and Copilot Tuning. Let's start with the new M365 Copilot app, where I'll show you how Copilot can reason over my GitHub backlog. This app is my 5-in-1 hub for work. It's got chat, search, agents, notebooks, and create. And here, I can call on agents, like the researcher agent. Researcher can reason over all my work data. And with the connector, it can even tap into GitHub. So let's ask for help analyzing performance issues and prioritizing my next steps. It goes ahead and it asks me a few clarifying questions, just like if I delegated this to someone on my team. I'll give it a bit more direction, and off it goes. Because it is built on the OpenAI O3 reasoning model, researcher shows its chain of thought as it pulls from both the web and my work data.
Bro, they're like,
I see here that it's giving me everything that I need, including some citations to help me get started.
It definitely pre-filmed too.
Now let me show you how I built this connector in Visual Studio. It takes just a few steps. I'll go ahead and add a name and a place to save it. And in seconds, the M365 Agents Toolkit gave me fully scaffolded code that I can modify, like creating my connection using the Microsoft Graph APIs. And then I can index any type of data. So here I've defined a specific schema for my scenario. Next up, I'm using the GitHub API to fetch my issues. And finally, I'll ingest every issue into Microsoft Graph, so Copilot can now reason over this data. So let's see it all in action. I see that all of my issues are being indexed, and I'm getting a full log of what's happening. As the log loads, I'll scroll up and confirm that my GitHub connection was made and that it has all the backlog items that I care about. So let's pivot to showing how the Copilot Studio can help us build agents with little code required. So here I've created an RFP response agent, which you can see right here in Teams. I see that it generated a proposal, and it even posted using its own Entra ID. So here you can see that we have a specific proposal that has the content, language, and format that you'd expect, for example, from an experienced employee. So let's go ahead and see how I built it. And for that, I'll jump over to Copilot Studio. Here, I've described what I want the agent to do, and I've given it some instructions. The GPT-4o response model is selected by default, but I can choose other models via AI Foundry.
It's so weird that they do use OpenAI's models.
Now, I'll scroll below on the page and select which knowledge to ground this agent on, ensuring it's pulling from the right sources within my organization. We'll keep scrolling on to the tools section, and I've added this trigger that prompts my agent to begin working whenever a new RFP arrives in my inbox. So now let's link this agent to the Dynamics MCP server to give it access to SKU and pricing data, and this will make for a more detailed proposal.
This is neat.
So
it makes it really easy, I will say.
It's now connected.
Wanting to mess more
this
with
server will keep the agent up to date automatically. It can also use third-party servers like DocuSign or custom MCP servers like this SAP one we created to access customer account data. The agent will need to be able to check compliance and contract terms. Now, instead of building this out from scratch here, I can just use the new multi-agent orchestration. As Satya said, this means that agents can now collaborate with each other to take on more complex work. So let's go ahead and connect this agent to one that specializes in compliance checks. With orchestration, the RFP agent can connect to the compliance review agent to ensure there are no red flags. If it passes, it'll now return back to this agent to continue the process. And with that, our RFP response agent is up and running. So now let's move to Copilot tuning, which Satya just announced. This is a low-code way to do what would otherwise take a whole team of data scientists weeks to do, fine-tuning a new model specifically designed for contract writing. And here's what it looks like in action. I'll open the contract builder agent, and ask it to draft the contract using a couple of example documents.
But I guess it's not fine-tuned on your contracts.
It's going to reference these documents and the custom model I created to assemble the contract. When the document is complete, I'll receive an email with the draft. Let's take a look at it. I see that this contract is using our company's language, terms and conditions, structure, and format. And here's how I built it. I'll start by creating a new model. I'll give it some basic information, a name, a description, and I'll select the task type, which in this case is document generation. Now I'll add the knowledge source.
What company is that?
Here we'll use our contract database from SharePoint. And I'll specify who should have access, so it's the contracts team and the procurement team. And then we'll ensure, so Copilot ensures that all of this access to knowledge sources in the tuned model is aligned. With that, our contract builder is now ready for data labeling. Now, once the subject matter experts have completed the data labeling process, we can complete the training for this fine-tuned model.
The humans still have to label the data?
Let's go ahead and publish it. And from the M365 Copilot app, the team can select Create Agent, select a task-specific agent, and select the contract builder model I just fine-tuned. And with that, the agent is ready. I've now scaled the work that I can deliver as a developer, empowering those closest to the business to reimagine their workflows with AI.
I honestly got lost like halfway through that.
Back to you, Satya.
Thank you so much, Miri. I mean, I'm so excited about Copilot Studio, and with access to the reasoning models, the ability to do things like Copilot tuning, these deterministic workflows. I mean, at some level, you can now think about these agents and multi-agent frameworks orchestrating the workflows in an agentic way for every role, every business process. I mean, especially once you start having even every business application just show up as an MCP server. You can imagine as a developer how you can start thinking about the next level of automation. I mean, it's just a complete game changer in terms of how we think about workflow and business process automation, right? Those SaaS applications and productivity software all coming together by role and process. So it's just an exciting day. To us, what we're doing is we're taking everything underneath Copilot, Copilot Studio, and making it available as a first-class platform for all of you as developers to build your own applications, your own application extensions, right? As models evolve and faster and become more capable with new samples being dropped like every couple of months, the apps will have to evolve to become these full, stateful applications that are multi-model and multi-agent, right? That's the big departure now, right? It's not about one model with just a request-response API call. We're building real stateful multi-model applications, and they have to be production-ready. And so that's what is the motivation for building a first-class app server. Think of Foundry like a production line for intelligence. It takes more than a great model to build these agents and applications. The system around the model, right, whether they're evals, this orchestration layer, or RAG, all really, really matter. And Foundry is that complete app platform for the AI age. Over 70,000 organizations are already using it across industries: BMW, Carvana, Coca-Cola, NASDAQ, along with many ISVs like Gainsight and others. They're all choosing Foundry, and enterprises are moving from just doing POCs to these enterprise-wide deployments to truly unlock the ROI of AI. In fact, over the past 3 months, we have processed over 100 trillion tokens, which is 5x year over year. In fact, when I was in Japan just recently, I saw this app built with Foundry that's helping people with auditory processing disorder make sense of what they hear, and it blew me away. Let's take a look at the video.
All right. Eason Corporation.
私は2歳の時に病気で耳が聞こえなくなりました。私は全く聞こえなかったので、この世の中には声というものがあると教えられました。
加藤さんとの出会いですが、加藤さんが YY システムを使い始めて、感動をして我々に手紙を書いてくれました。その手紙の内容は、生活が変わり始めている。
一番困ることは会話ができないことです。
日本の中でもいろんな方言があります。ですので、いろんな地域性の喋り方とか特有の言い回しっていうものに対応。自分の声で話して、それを文字にして伝えたいという要望が結構たくさん出てきたというところが、ありまして、マイエンジンの開発を行うことにしました。私たちは Azure AI Foundry をたくさん使わせていただいています。主な使い方としては、発言を修正するためのロジックを検証したり、あと翻訳を適切な翻訳になるための検証するための検証ツールとして使っています。私たちは Azure スピーチサービスをリアルタイムの文字起こしに主に使っています。それ以外にもろう者の方の声の学習をして、その方専用のモデルを作るカスタムスピーチモデルというものに使っています。おかげさまで私たちの YY システムのアプリケーションは日本国内で145万ダウンロードを突破いたしました。
私は子供、孫の声が話がわからなかった。それがわかる会社でも加藤さん、今までは分からなかった。加藤さん、何？
Bro, if she's deaf, why would you be calling her though? Like, that's kind of fucked up.
教えてあげれる。
私は、ただのエンジニアでした。ですが、アプリを出したことによって、本当にユーザーさんの声が僕を支えてくれている。本当にそういう感覚です。それが自分のこのエネルギーというか、モチベーションにつながっていると思います。
Nice little heartwarming story.
Really a big thank you to all the developers at iShin and Kato-san for sharing that story. It's really inspiring. You know, today we're going further. It starts for Foundry with model choice. You know, we already support 1,900 models, whether they're response models, reasoning models, task-specific, multimodal, you name it, they're all there in Foundry. And of course, that includes the latest from our partners at OpenAI. Just this year, we have shipped 15 models from OpenAI on Azure, giving same-day access when a new model drops. And Sora is coming next week. As devs,
it seems so weird that they
care
talk
about
this. I don't
multiple
know.
dimensions, right? Cost, reliability, latency, as well as quality. And Azure OpenAI is best in class. We offer enterprise guarantees like high reliability and great cost controls, things like batch or spillover, and of course, leading security and compliance and safety. But you know, still, picking a model can be a bit of a chore, and you need to be able to route your queries to the right one fast. And so we are making that easier too. Our new model router will automatically choose the best OpenAI model for the job. No more sort of those manual model selections. An approach today, though, goes from having apps that you build or agents you build only bind to one model to truly becoming multi-model.
That's interesting.
That's why today we are thrilled to announce Grok from XAI is coming to Azure.
It's like, do we clap or?
You know, Grok 3 offers reasoning, deep search, response models all in one single model.
Grok has
and
always
it was
been pretty
awesome
underwhelming
to have a chance to chat with Elon over the weekend about it. Let's roll the video.
All right.
Thank you so much, Elon, for being here at Build. I know you started off as an intern at Microsoft. You were a Windows developer, and of course, you're a big PC gamer still. You want to just talk about even your early days with Windows and the kinds of things you built?
Yeah, well, actually it started before Windows with DOS. I had one of the early IBM PCs with MS-DOS, and I think I had like 128K in the beginning, and then it doubled to 256K, which felt like a lot. So I programmed video games in DOS, and then later in Windows. Remember Windows 3.1?
Yeah. No, it's wonderful. I mean, even the last time I chatted with you, you were talking all about everything, the intricacies of Active Directory. And so it's fantastic to have you at our developer conference. Obviously, the exciting thing for us is to be able to launch Grok on Azure. I know you have a deep vision for what AI needs to be, and that's what got you to get this built. It's a family of models that are both response and reasoning models. And you have a very exciting roadmap. You want to just tell us a little bit about sort of your vision, the capability, you're pushing on both capability and efficiency. So maybe you can just talk about a little bit of that.
Sure. So yeah, with Grok, especially with Grok 3.5 that is about to be released, it's trying to reason from first principles. So apply kind of the tools of physics to thinking. So if you're trying to get to fundamental truths, you boil things down to the axiomatic elements that are most likely to be correct.
Crazy he's talking about that right now, considering
and then you can test your conclusions against those axiomatic elements. And in physics, if you violate conservation of energy or momentum, then you're either going to get a Nobel Prize or you're wrong, and you're certainly wrong, basically. So. That's really the focus of Grok 3.5 is sort of fundamentals of physics and applying physics tools across all lines of reasoning, and to aspire to truth with minimal error. Like there's always going to be some mistakes that are made, but aim to get to truth with acknowledged error, but minimized error over time. And I think that's actually extremely important for AI safety. So I've thought a lot for a long time about AI safety, and my ultimate conclusion is the old maxim that honesty is the best policy.
Yeah,
it really is for safety. But I do want to emphasize, we have and will make mistakes, but we aspire to correct them very quickly. And we are very much looking forward to feedback from the developer community to say, like, what do you need? Where are we wrong? How can we make it better? And to have Grok be something that the developer community is very excited to use, and where they can feel that their feedback is being heard, and Grok is improving and serving their needs.
I'm really thrilled to get this journey started, getting that developer feedback, and then looking forward to even how they deploy it. So thank you so much, Elon, for briefly joining us today. And we're really excited about working with you and getting this into the developers' hands.
Thank you very much. And I can't emphasize enough that we're looking for feedback from you, the developer audience. Tell us what you want, and we'll make it happen. Thank you.
All right. It is interesting that they are offering it on Azure.
I had a chance to talk to him again, and then he was talking about sort of all the things that they're doing with 3.5. So we want to get the journey started, get the feedback on the API front, and sort of help them with their roadmap. We're excited about sort of all these new announcements. And one of the things, though, when you have multiple models, what you need is a new capability in how you use these models. And now you can provision throughput once on Foundry, and you can use all that provision throughput across multiple models, including Grok, right? That's just a game changer in terms of how you think about models and model provisioning. And so now, once you do that, you now have Mistral, with which you can even provision with all the sovereign deployment in the EU region, which increasingly becomes a massive consideration for people building applications around the world, because I think increasingly there will be models people prefer in different parts. And we're excited about Mistral. Llama, I was at LlamaCon recently with Mark, and as he likes to say, he's bringing the full herd of Llama, the full Llama herd to Azure. We're excited about all the advances that they're making in open source, Black Forest Labs, and many more, right? So all of them, all behind this one provision throughput. And so it's exciting for us as developers to be able to mix and match and use them all. Many of them have the same API signature, so even the ability to be able to make these model switches becomes even easier. And we also have expanded our partnership with Hugging Face. So you'll have access to over 11,000 frontier and open source models in Foundry. But models are just part of the equation. For anyone building an agent, and truly you need to be able to have truly great access to real-time web, as well as the entire enterprise knowledge graph. We've learned that building RAG apps, that you need a more sophisticated retrieval system, right? It's not good enough to just have a vector search and some embeddings. And you really need like a database or a knowledge engine, a real query engine that's custom built for agents, and so that you can break down any a complex query, run them in parallel, return synthesized results. Think of it essentially like a modern knowledge retrieval stack for agents that understand what users want and what your data means. And of course, once you have even that part of the system, the next layer is the orchestration layer, right? You want to be able to have all these agents or multiple agents orchestrated. And the Foundry Agent Service lets you build declarative agents, in fact, just with few lines of code just in the portal. For complex workflows, it supports multi-agent orchestration. It integrates seamlessly with frameworks like semantic kernel, AutoGen, and you can use the agent service essentially like a managed service for the execution environment. And more than 10,000 organizations are already using it, and I'm excited to share that now the agent service is generally available. Once you have these agents running, the next thing you need is the compute environment. And we're making everything from serverless Azure functions to Azure container apps to the extreme control that you need with sort of AKS and how you scale. We're providing full spectrum of compute so that you can hit that right price performance for any of your agentic scenarios. And we're making it straightforward, for example, for you to connect Foundry to your container app or functions and deploy any open source model into AKS, whether it's in the cloud or in hybrid mode with Arc, right? Increasingly, you want to even have these models that get deployed at the edge, and Foundry will support that. And we're closing the gap and the loop between Foundry and Copilot Studio. And this is pretty key for us as developers, right? You can now take a model, fine-tune it or post-train it in Foundry, and then drop it right into Copilot Studio so that you can now use that post-trained model to automate a workflow or build an agent, right? So that's the type of stuff that you can do.
Yeah, this is directly competing with Google here.
One fantastic example of this is what Stanford Medicine orchestrated using multiple agents to connect, right? From patient history to radiology, to getting PubMed data,
I love seeing real-world
clinical trial data,
and
many other scenarios. But one goal, which is how can they take something mission critical like cancer care and a tumor board meeting and orchestrate it all with AI. It's pretty incredible. Let's take a look at the video.
Stanford Medicine is at the forefront of cancer research. In the context of treatment, tumor boards are a really important meeting of many different clinicians who convene because a patient presents in a way that they're not familiar with.
You have to pull together information about medications, any procedures, radiology, labs, a patient's history, as well as the medical literature. There's not just a lot of information that you need to bring together for the tumor board, it's that information is fragmented in a bunch of different places.
Stanford runs about 4,000 tumor board meetings per year, pulling through real-world evidence, pulling literature, pulling clinical trials. Those are things we do manually, and we can't do them 4,000 times per year.
The healthcare agent orchestrator is a way of bringing all this together at the beginning so that we can help make patient decisions more efficiently, faster, and perhaps more accurately.
This is an agentic AI solution deployable through Azure AI Foundry. We've been able to build, customize, and deploy our own agents, with this first use case being a tumor board.
Cool.
There is an orchestration layer that allows all of the different agents to dispatch and to provide a comprehensive report to a clinician that brings together all of these disparate information sources. And this really powerful thing that Microsoft has incorporated into its agents is grounding within specific clinical notes.
They're already using Word to summarize things. They often make PowerPoint slides. This enables us to put everything in an integrated setting into one summary.
It took just a few lines of code to deploy these agents into Teams so that we could start interacting with them directly.
The more integration between all these systems, the less effort they're spending on those mechanical things, the more effort we can spend at actual decision-making that we're experts at.
It's being delivered as a platform on which we can build. We can package things to share with others so that community hospitals get access to the same kind of capability that an academic medical center does.
If we work faster and we come to better decisions with better information, that itself, that's a revolution.
We want to develop tools that will not only help our physicians at Stanford, but help physicians all over the world. I think it's going to be transformative.
And I'm really thrilled to share that this healthcare agent orchestrator that Stanford used is now available to everyone in Foundry. It's pretty awesome. You know, quite frankly, when I see that video is when I know things are becoming real. You know, think about it, right? Which is you use multiple models in Foundry, you do this multi-agent orchestrator, you bring it together in Copilot and in Teams, and a real-world example of some workflow orchestration done in an agentic way. That's when you know you're going from like one little app to something that can scale throughout the enterprise. So speaking about scaling to the enterprise, the other important consideration for an app server is observability. So that's why we now have new observability features coming to Foundry to help you monitor and manage AI in production.
That's definitely a problem
you can
with
track the impact,
LLMs.
quality, safety, as well as cost all in one place.
Hard to see inside.
And it goes beyond that. In the future, we believe every organization is going to have people and agents working together.
API calls.
And that means the systems that you're today
MCP
using
calls.
ubiquitously for things like identity, management of endpoints, security, will need to extend to agents as well. That's a big deal, right? You want the same rails that you use today at scale to work across people and agents. And that's what we're doing. With Entra ID, agents now get their own identity permissions, policies, access controls. The agents you build in Foundry and Copilot Studio show up automatically in an agent directory in Entra. We're also partnering with ServiceNow and Workday to bring automated provisioning and management to their agents via Entra. And when it comes to data governance, Purview now integrates with Foundry, right? So when you write an agent automatically, because of Purview, you can ensure end-to-end data protection, another massive safety consideration. And on the security side, Defender now integrates with Foundry. So that means your agents are also protected, just like an endpoint would be, from threats like wallet abuse or credential theft with Defender. And this is just a quick look at Foundry, your agent factory. Now, to make all this real, I would love to invite up on stage Kadesha, one of my colleagues, to show you how it all comes together. Kadesha, take it away.
Thanks, Satya. Today, I'm going to show you how you can use Azure AI Foundry and GitHub Copilot to make your dev life a whole lot easier. This is Vibe Travel, a chat-based app that uses Azure AI Foundry to provide an AI travel agent to help people plan their trips. I'm planning a trip to New Zealand in about 8 months, so I asked Vibey for places to ski. This math isn't mathing. I'm pretty sure 8 months from now is January 2026, and think about it, that's going to be the summer season in the Southern Hemisphere. We definitely need to make our AI agents smarter and give more grounded responses.
Yeah, bro, this is
I can
more
pop
about
into Foundry and see all of the AI agents that we have for this and our other apps.
It does make it look
Our Vibe Travel
easy to
agent
make.
uses GPT-4o and has a pretty great prompt, but we need to add some knowledge. We can do this by giving it files with reference data or connections to other services like Microsoft Fabric or TripAdvisor. But I think we can get a long way by just adding grounding with Bing search, so let's choose that option.
Bro, TripAdvisor is clearly the better option,
Really
let's be real.
simple. In addition to giving it access to knowledge, we also give it access to our flight reservation API. And because it's an open API, it just works.
That's
now,
cool.
let's go back to our app and try our query again.
Whoa.
Being able to add data sources or search capabilities makes the agent smarter and far less likely to hallucinate. I could make it even smarter by adding information about hotel discounts or weather forecasts. The possibilities are endless. In about 8 months, it's January 2026, which is the summer season. No skiing possible. That is much better. And you saw how easy it was for me to improve. Now, let's have the agent actually book a flight on my behalf. Adding actions that the agent can perform upgrades the app from a simple question answering machine to an autonomous agent that can actually do things on your behalf. I could use an action to put that booking in my calendar, or request to book a hotel, or even to request leave from an internal system. Now, these flights look great. You just saw how Foundry made it easy to improve our agents, but there's still plenty of work to do in the actual code. I'm going to use agents in GitHub Copilot to get this done. Let's open Copilot agent mode, which is new, by the way. And I can choose between the most popular and the most powerful models from all the major LLM providers. Agent mode takes GitHub Copilot beyond just answering questions or suggesting code to actually helping me do the work. I can come in here and I can ask, can you show me the issues that are assigned to me in this repository?
I mean, I'll have to give Copilot a go now that I canceled my cursor
I would have opened the
subscription.
browser to look at the issues on github.com, but with MCP or Model Context Protocol, this allows you to give tools like GitHub Copilot the context and capabilities it needs to help you. GitHub Copilot will notice that we're asking about GitHub issues and uses GitHub MCP server to get that information. And it looks like I have a few issues assigned to me, so let's have a look at the first one. Now, when I click this reset button in the app, it immediately clears our chat session without a warning. That's not ideal. We should really warn people first. Let's go back to the app, and I can ask GitHub Copilot to help me implement the details for issue number 1 and also fetch the details for issue number 1. I also have this beautiful design that my manager gave to me last minute that I need to add as context to the prompt as well. I hope you can see it. So let me pull up my screenshot for you so you can see that.
Instead of like Tailwind or any other like styling.
Let me add this to the context window and send the prompt. We'll see Copilot asking for specific permissions to use the GitHub MCP server to fetch the details of the issue. Let's hit continue to allow it to implement the changes in our code base. You can see the GitHub MCP server fetch the details, and with agent mode's new vision capabilities, it means that Copilot can even understand the sketches of what I want. Then it starts working out the issues of what I want to change and figure out how to change it. While it's doing that, let's take a look at the other issue. And actually, I cheated a little for this one.
Really?
Before I came out, I assigned the issue to Copilot, just like you saw Satya did earlier with the Azure Dev Community website. Copilot has looked at this issue and opened up a pull request for us. Let's take a look at it. You can see here it has a description with implementation details and the code changes that it recommends. We can also see the full session log of how GitHub Copilot implemented this change by clicking this View Session button and scrolling through the changes.
This is cool, actually.
Let's take a look at the actual code, though. This looks good, but if I want to add some feedback, I can do that by popping in a comment right in the issue or in the pull request, and GitHub Copilot is going to take a look at it and get started on the work. You can see the little emoji right here. You know, it actually feels really good working on 2 issues at the same time. Now, let's go back to our editor to see the progress on issue number 1.
I wonder what this costs.
As you can see, Copilot Agent Mode was able to examine the proposed changes, look for relevant files to change, make the changes as appropriate, and it even stuck to the styles and coding standards that I wanted it to. When I go back to the app, it was able to implement the UI changes that my boss wanted. Let me see if it's running. That's it, keep. As you can see, folks, this is live.
What is it? It looked pre-recorded, honestly. Maybe they should have actually kept to the pre-recording. Uh-oh.
Don't have time to debug, but once I click this issue, I'm pretty sure it's implemented. Copilot was able to add the modal in our app, and that's 2 issues that we worked on in a handful of minutes. Thank you, GitHub Copilot and Azure AI Foundry.
I mean, this is Codex, exactly what OpenAI just launched.
While I'm here, it's not often that I get the chance to check on Satya's work.
Yeah.
So let's take a look at the issue that he assigned earlier. Do you remember it? To add that group size filter to the site. Let's take a look at it.
If this one isn't pulled through, it's over 2.
Oh, we're already here. Okay, so this is the issue, as you see. And Copilot was able to open up a pull request to start implementing these changes. Let's take a look at the PR. So as you see here, Copilot was able to add the group size filter property. It was able to add the logic for Redis caching, and it also added some testing with instructions. That's pretty sweet. Now, it's also deployed the app to our staging environment. So let's take a look at the deployment. Fingers crossed. Let's scroll all the way down. And you can see the group size filter was added.
All right, at least one pull through.
I do see a couple of things that I want to tweak, but I'll work on that backstage and then push to production later so you can take a look. That's 3 issues in a handful of minutes. Back to you, Sarga.
Thank you so much. Yeah, talk about working hard in parallel. You know, it's really exciting to see the progress that we're making with really building out. Like each one of these platform shifts has needed an app server, and building out that fullness of the app server is when you know that the platform shift is now taking scale. And now, so far we have talked about everything we're doing in the cloud. Now, we want to bring the power of this app server and app building capability to the edge and clients as well with Foundry Local, which we're announcing today. It includes a very, it includes a fast, high-performance runtime, models, agents as a service, and a CLI for local app development. And yes, it's fully supported on Windows and the Mac. And
So now let's just step back and talk about
this could be
Windows
interesting, I guess,
for a moment.
Because it's not enterprising.
If you're a developer, Windows is the most open platform with massive scale, with over 1 billion users and billion devices that you can reach.
It will be,
and we're constantly improving it, right? Making it more secure, more reliable, better for your apps, no matter whether you want, where you want to run, in fact, the Windows image, right? Whether it's on the cloud or on the client machine. In the past year, we have seen developers from Adobe to Zoom use these on-device AI capabilities on Windows to ship some amazing applications. If you go to the store and the AI hub, I mean, you can start seeing many of these things light up. And today, we're taking another step to make Windows the best platform for AI. We're excited to announce the Windows AI Foundry.
What does this mean?
Yeah. Windows AI Foundry is what we used, in fact, ourselves internally to build features like on Copilot Plus PCs for things like recall or even click to do. All of these now are built using the same runtime and the SDK. And now we're extending this platform to support the full dev life cycle, right? Not just on Copilot PCs, but across CPUs, GPUs, NPUs, all, and in the cloud, right? So you can build your application and have them run across all of that silicon. And Foundry Local is built into Windows AI Foundry, so you can tap into this rich catalog of these pre-optimized open source models that you can run locally on your device. And with Windows AI Foundry, you can customize. This is very, very cool. Our built-in Phi Silica SLM using LoRa adapters.
Actually, I think you're right. Yeah, that's probably what this is.
And to sort of basically meet any specific need of your application, right? You have, think about it, it comes with, the image comes with Phi Silica. You just do a LoRa adapter in your application, and it just works. And if O1 and DeepSeek marked the beginning of basically inference or test time compute in the cloud, I think Phi Silica is going to completely revolutionize what inference compute on the PC is going to look like, and you all as developers are going to truly exploit that to build some amazing experiences. And beyond the model itself, you now have all these rich semantic APIs to embed and index your local data into a vector store, right? With all the privacy protected. And then you can do these hybrid RAG applications, right? Where when you do a RAG, you can actually get to the local data and have it
how much RAM we have, how much
contextually relevant. And if you're building your own models, Windows ML gives you a path to deploy high-performance AI across a variety of silicon without the complexity of all these device-specific tuning. And today, we are taking the next step, modernizing Windows for the agentic web. We're announcing native support for MCP in Windows.
That might be interesting,
Windows will now include several built-in MCP servers, like file systems, settings, app actions, as well as windowing. And we're adding native MCP registry that lets MCP-compatible clients discover these secure MCP servers that have been vetted by us for security, performance, all while keeping you in control. Let me hand it over to Divya to show you all of this and how it works and how it comes together, both as an app developer and also as a user of applications on Windows. Divya, over to you.
All right, I'm actually curious.
Thank you, Satya. Today, I'm going to show you how easy it is to set up a new Linux distro, build a complete website project, and update with my Figma design, all with just 3 sentences in VS Code, using GitHub Copilot and MCP on Windows. First, let's make sure we're set up correctly. For agents to connect to MCP servers, apps need explicit user permissions. In Settings, you will see that I have already enabled WSL in Figma, so their MCP servers can be easily accessible to agents.
This is MCP.
Other apps remain in their disabled default state, putting me as a user in full control. Now that we're all set up, let's dive into VS Code and use my first two sentences.
System?
I have the VS Code open with GitHub Copilot, and this is also in the agent mode, as you can see. I'm using my first two sentences, and I'm asking GitHub Copilot, can you search for the latest version of Fedora in WSL and install it for me? Once it's installed, can you also set up a simple website project in Fedora using Node.js? I hit Enter, and Copilot here is trying to establish a secure connection with the WSL MCP server. And it gives me first of my several quick user consent prompts. I hit Accept and allow it to proceed. Behind the scenes, it's also trying to query the list of available online distros, finds that Fedora 42 is the latest version, and proceeds to install.
So do you have to use it within VS Code still,
as you can imagine, can take roughly about 2 to 3 minutes.
That's not really what I got
from
that.
So let's switch over to a device where this setup is complete. So on this device, I've got the environment set up. Let's scroll back up and see what steps it executed for me. As you can see, it's the exact same prompt. GitHub Copilot in the agent mode was smart enough to parse this multi-step request pretty seamlessly. It also queried the WSL online distro, set up the Fedora environment for me. It also installed the Node.js NPM directly inside Fedora using the DNF package manager. The best part here is it also knew how to run specific commands directly interacting with WSL on my device. That's pretty neat. Now let's go take a look at the simple website project it created for me. Well, this is a start. I'd like to take it one step farther and make it look like the design I've selected in my Figma. So here's my Figma desktop app, and here's the design I've selected, Penguin Pen Pals. So now I'm ready to go back to VS Code and use my third sentence.
All right.
So I'm going to ask GitHub Copilot here, can you make my website look like the design I have selected in Figma and pull the design details and apply them to my project? But you can see the detailed prompt in the chat. Now I enter, and Copilot here, again, is establishing a secure connection with the Figma MCP server and asks for my consent to proceed, and I obviously accept. Before doing that, it queried the list of available servers in my MCP registry, found that Figma was the most relevant one to perform this task, and it proceeds to connect. Once connected, the agent pulls the design details directly from Figma, integrates them into my project, and updates the site's layout, design, style, and content accordingly. This could take roughly about 2 to 3 minutes. Let's switch over to another device where this final step is complete. So on this device, the whole setup is complete. On the left side, you will see the code changes it applied by pulling the design details from my Figma desktop app. Now it's the right time for us to go take a look at the website it created for me.
And then a JS file.
Boom. This is exactly the design I selected in my Figma desktop app.
I know it's like pre-recorded, but I thought it was going to be more so like...
It did all of this in just 3 sentences in a single chat interface. This is just one example of a developer-centric scenario I showed you today. Imagine what other incredible opportunities this can unlock for you, enhancing your productivity, all while remaining secure. This is the power of MCP on Windows. Secure, agent-driven, and developer-first. Back to you, Satya.
Yeah, I mean, that's cool. I thought it was more so like you.
Thank you so much, Divya.
Just
As
normal
you saw,
Windows
with
use, you could access MCP. Maybe you can.
And WSL.
But that was
We're
neat.
really
I do like
making Windows the best dev box.
Native MCP server on Windows is kind of cool. That's interesting. I'm looking to host one. I have a Zima board or like a Raspberry Pi or something.
Windows nearly 10 years ago. It subsequently became what we obviously call, today WSL. Looking back, in fact, the very first issue
is kind of annoying, though, if I'm being honest.
In the repo was a request to open source it. At that time, all of our logic for the project was quite inseparable from the rest of the Windows image. But since then, with a lot of the changes we made, WSL2 distros are more separable and they're standalone. So let's go back and reopen that very first issue and close it as fixed, because today we are making WSL fully open source.
Interesting.
You know, so far we've talked a lot about the agentic web and the ecosystem around it coming together, whether it's Microsoft 365 to Foundry, all the way to Windows. And I thought it would be great to have Kevin Scott, our CTO, to give you a broader perspective on this ecosystem and our collective opportunity to build a more agentic web. Welcome, Kevin.
All right. Thank you, Satya. So it's super good to see you all. I think this is my 9th build as CTO of Microsoft, which seems like a really long time. And like I get to come out here once a year to talk to you all. Forget that I'm an introvert for about 15, 20 minutes. And it's not like there's some magical thing that happens every May that makes me forget that I'm an introvert. It's just that there have been so many exciting things that have happened in the universe of technology over the past year, and there's so many things that are coming in the next year that I just want to share some of that enthusiasm with you all. And the thing that is really exciting me right now is something that is emerging, not solely because Microsoft wants it to happen, but because the components and the protocols and services that we've all been collectively working on for the past few years are sort of forming this thing that we've been calling the agentic web. And the thing that's really, really encouraging about it is that it's happening in an open way, which I think is the thing that we all should want a whole lot, given where we're headed. I'll explain a little bit of why that's important in a minute. But before we go into the architecture of this open agentic web, let's talk about what an agent is. So I know you all probably have a bunch of different definitions in your head. You know, it's a little bit like a Rorschach test, but the thing that I always come back to and what we're pushing towards here at Microsoft, both in terms of the agents that we're building ourselves, as well as the capability that we are trying to create to help ourselves and to help you all make your own agents, is that an agent is a thing that a human being is able to delegate tasks to. And over time, the tasks to which you are, the tasks that you're delegating to these agents are becoming increasingly complex. And that's the thing that we're aiming for over time. The thing that we've seen over the past year is just sort of an explosion of agents themselves. So this is our diagram of what the agentic web looks like. And at the very top of the stack is like a richer and richer ecosystem of agents that we're building, our partners are building, that you all are building, and we're just going to see more coming over the next year. And the striking thing about what's happened with these agents over the past year is that they're being used more and more frequently than ever before. So across the agents that we have visibility on, the daily active users since I was here last time chatting with you all at Build have more than doubled. So just people using them at an incredibly increasing and accelerating rate. But the bigger thing that I think has happened is that these agents, because of the new reasoning models that have launched over the past year, have been able to really take on extremely complicated tasks. And you've seen a whole bunch of this stuff already from Satya and from the folks who've been on stage to provide demos. Just the incredible things that some of these agents can do right now, particularly in software engineering. And you guys are going to see more and more of that over the course of Build. But sort of sitting on top of the agent layer of this agentic web stack is a thing called the runtime layer. And the runtime is again, sort of an emerging set of components that we are building. The thing that I just mentioned that's gotten really good over the past year is the reasoning layer, or the reasoning component inside of the runtime layer here. The reasoning capabilities of these models is going to continue to get better and better. If anything, right now, I think we have a little bit of a capability overhang with reasoning. So the models are more powerful than what we collectively are using them for at the moment.
That's
and
an
like one of my
interesting
big
take.
challenges to all of you this year at Build is to just sort of think about how you can set your ambition level to 11, like to try to target some things that are you think are barely possible right now in terms of reasoning capability. Because the models are going to get so much more powerful and so much cheaper over the course of the next 12 months that like we don't want that capability overhang getting bigger than it already is. But there are a whole bunch of things in addition to reasoning that need to be built that are just sort of basic software engineering. A thing that's been conspicuously missing for a while with agents is like really robust agentic memory. We've approximated it a bunch of ways with things like RAG and with long context windows. But the thing that you really want your agents to be able to do is to like have a rich memory over which they can recall with real breadth, and where you can have high precision in the recollection so that the things that are being pulled back out of memory are like accurate and you can trust them and rely upon them. And so there's just super interesting stuff happening. Like we open sourced a system called Type Agent that you all can learn more about later here at Build. That is one way that we're trying to tackle this agentic memory, which is just really important to make them less transactional. So they can solve a problem once and recall the solution. They can remember their interactions with you so that like they can become personalized and understand your preferences. The same way that you would expect from someone that you were delegating a task to or that you were collaborating with. So this whole runtime layer, the way that you can think about how Microsoft is delivering these components and participating in the community is these things are going to be offered in Azure Foundry. Azure Foundry is going to get richer and richer and richer over the coming year, and you're going to hear my colleague Jay Parikh and a bunch of other folks talking about that Foundry layer and this runtime in much greater depth. But the thing that is super important if you think about what an open agentic web could be, is you need agents to be able to take actions on your behalf.
Yeah, the protocols, standardization is very important.
Things about agents being able to take actions on your behalf is they have to be plumbed up to the greater world. So you need protocols, things like MCP and A2A and things that likely are going to be emerging over the coming year that will help connect in an open, reliable, interoperable way the agents that you are writing and the agents that are being used so actively now by hundreds of millions of people to be able to go access content, to access services, to take action on behalf of users in fulfilling the tasks that have been delegated to them. And so the super exciting thing that we really want to talk about here at this Build is our real serious commitment to MCP. So MCP has just taken off like crazy over the past handful of months, and there's a good reason for it. It's filling an incredibly important niche in this open web, open agentic web ecosystem. It's a very simple protocol, like akin to HTTP in the internet, where it allows you to do really sophisticated things just because the protocol itself doesn't have much in the way of opinion about the payload that it carries. Which also means that it's a great foundation which you can layer things on top of. And if you think about how the internet itself emerged, like that composability of components and layering of protocols was really important to get to the richness. It gives you good starting places, and it gives you the ability to solve problems as you discover them as things are developing over time. So, you know, we have heard from Satya, like just now, about the MCP registry in Windows. Like we're doing a ton of work to enable Microsoft's first-party platform components and first-party services to be MCP uplifted. Like we've chosen it as our standard protocol for agentic communication, like between agents and from agents to services. And then we're going to be doing a whole bunch of work over the next handful of months with our partners and collaborators at Anthropic to make sure that the really tough enterprise problems that need to be solved on top of a protocol like MCP get resolved and solved. like how an agent identifies itself, how you build a really rich entitlements infrastructure so we can permission agents to have access to the systems they need to have access to. And then we're going to be just really, really supporting the open community here. Partially that is because, like when you think about the utility of a protocol at this layer of the stack, the most important thing is ubiquity. We can get into all sorts of arguments, and I know you all are perfectly capable of this, as am I, as engineers, like where you've got really sharp opinions about pieces of technology and like, you know, this thing's a little bit better than that thing. But what's better than all of that is like just getting something standard that we can all use and build on top of. And
Not
like
wrong.
we hope that thing is MCP.
And we need that for mass adoption too. There's a lot of enterprises that are more conservative need.
The thing that I want to talk about next is, you know, I mentioned layering. And so
standardization.
If you think back to the web, you know, we have HTTP. And then we had things that sit on top of HTTP, like HTML mainly, that are opinionated about the payload. And so we're announcing today, and you all should go check out the code in the GitHub repo, NLWeb. And the idea behind NLWeb is it is a way for anyone who has a website or an API already to very easily make their website or their API an agentic application. It lets you implement and leverage the full power of large language models to enrich the services and products that you're already offering. And because every NLWeb endpoint is by default an MCP server, it means that those things that people are offering up via NLWeb will be accessible to any agent that speaks MCP. So you really can think about it a little bit like HTML for the agentic web. We have done a bunch of work already with partners who have been really excited and been able to really very quickly get to quick implementations and prototypes using NLWeb. We've worked with TripAdvisor, to TripAdvisor, O'Reilly Media, a ton of like really great companies that offer important products and services on the internet to add NLWeb functionality to their sites so that they can have these agentic experiences directly on their sites. And one of the things that I wanted to show you all to just sort of ground you in the capabilities is like how you all might be able to go out right now, although you shouldn't do it right now, like wait to hear all of the amazing finish of Satya's keynote, please. But like right after that, you can go grab code from this depot, and like what we're showing here is a way for you all to put an agentic NLWeb user interface on top of any GitHub repo that you have access to. So what we're showing on the screen is like you run this Python script, it talks to the GitHub API, it extracts a whole bunch of data from your GitHub repo. Here you're seeing Jennifer Marsman, who's a member of my team in the office of the CTO, who's the best demo builder on the planet, who is like getting all of the metadata and data out of her repos into a NLWeb repository. The second thing that you do is you go run a little script that takes all of this data, computes a bunch of embeddings for it in this case, and you have a ton of choice here about which model you're using, which embeddings you're using, which vector store that you're sticking the embeddings in for the NLWeb server to have access to. And as soon as you compute the embeddings and import them, in this case, into a local vector store that's running on her laptop, then you're able to make some really interesting queries on top of it. So in this case, like you can do more than what you would get just with a database query or some kind of information retrieval thing. You're able to say like, hey, I wrote this piece of code. It was in some PR I don't remember. Like I need to recall the name of this algorithm. And like that's the sort of thing that NLWeb can do. And like things that we honestly aren't going to even be able to imagine, which is why we're making this open source, and we're hoping to hear a ton of feedback from you all about how we can improve and make NLWeb better. Because again, like we think that the sum total of your imagination operating on the agentic web is going to make the agentic web a fundamentally more interesting thing than we would have if one entity was trying to do everything alone. So you can learn more about these things.
This guy's much more
these
grounded.
two talks
I like
in particular. So there is a fantastic talk at 4:30 to 5:30 today on how you can turn your website into an AI app. And then the memory stuff that I was referencing, we've got a talk from 1:45 to 2 p.m. today that is going to be really awesome. So the last thing that I want to say before handing things back over to Satya is to just sort of press on these like 2 points about why like open is so important here. So, it is unbelievable what can happen in the world when simple components and simple protocols that are composable with one another are out there, exposed to the full scrutiny and creativity of every developer in the world who wants to participate or who has an idea. This, thought game that I play with myself all the time is like trying to imagine what the web would have looked like if one of the actors in the early development of the web, like say the browser manufacturers, had decided that they wanted to vertically integrate and own the entire web. 100% of the web would have been dictated by the limits of their imagination. And it's just obvious with 30 years of history that wouldn't have been a very interesting web that we would have had, because the web is interesting because millions, tens of millions, hundreds of millions of people are participating to make it into this rich, dynamic thing. That's what we think we need with the agentic web, and that's what we're hoping you all can get inspired to go work on a little bit, and to riff on, and to use the full extent of your imagination to help make this thing interesting. So thank you all for being at Build. See you next year.
Good way to end. Optimistic.
Thanks so much, Kevin. The agentic web vision that Kevin just described, in some sense, gets us closer to even the original vision and the ethos of the web. Both the content as well as the intelligence now can be more distributed and discoverable across the web, right? NL Web, if you sort of look at it, it's a pretty fascinating thing. I'm really I'm looking forward to seeing what all of you make of it. But it democratizes both the creation of intelligence, right, for any app, any website. But here's the interesting thing. It democratizes the aggregation of this intelligence for any developer, right? You can easily see it. Give me a sort of a reasoning model, an NL Web, and I can take an intent and start composing using the reasoning model to go compose and synthesize across that distributed intelligence. It's just a completely, what is search, what is a feed, any of these things gets completely changed in terms of how one goes about building it, right? So this is a platform that we want to create together. I think something big is going to shake out of this, because this is not just the repeat of the past.
We still got a while until
years,
people are still going to
always been about sort of the aggregator power.
Like humans, they're still going to be using websites still. It's not like it's just AI agents right now. To the next layer of the stack, data. After all, for any AI app, the data tier is super important. Yeah, arguably a bottleneck right now.
We're building out the full data stack. There are so many great examples, whether it's Lumen using Fabric to save over 10,000 hours because they can access data faster, or Sitecore delivering 10x speed with our data stack. But one of my favorite examples is NFL, which used our data stack to run the recent scouting combine. Let's take a look at the video.
Interesting.
Success in the NFL often comes down to one play, 1 second, one thing that's done better than your opponent. Data is a big part of that.
Like Moneyball.
The Combine is an event that brings together the top 3% of draft-eligible football players. In the early years, we were collecting the same amount of data, but it was scattered across different systems.
Teams didn't have a way to filter, search, and compare these stats without digging through multiple reports. AI was a perfect way to get that full prospect view.
We had a very short runway to get this all put together before we kicked it off.
Azure AI Foundry gave us the tools that we needed to hit the ground running. We started with the Azure OpenAI GPT models that we didn't need to fine-tune. We had Azure Cosmos DB to quickly store and retrieve that data, and we have Azure Container Apps to deploy the workload seamlessly. It was like a big challenge that we solved in no time.
Now, teams have the ability to ask questions about specific players and immediately be able to obtain data that allows comparative analysis from player to player. It really gives evaluators an edge that we didn't have previously.
Being able to ask a question as I would ask you a question, like, give me the fastest 40 times of a defensive lineman. The filtering of data that would have taken hours is done in a matter of seconds.
The ability to collect data in real time and dig deeper into the details while the player's in front of you, it makes you more confident in your decision making.
Yeah, that's a good use data analysis with AI.
Yeah, sports and data, it's the most fun.
Yeah,
just love that,
heavy,
and we're making a ton of data news at Build, starting in fact with SQL Server 2025 that's launching, and more importantly, we're bringing the data layer and the intelligence closer than ever before. Right? For any real-world agent, you require the storage, and that's why we're integrating Cosmos DB directly into Foundry. So that means any agent can store and retrieve things like conversational history.
Cosmos DBs, they're like NoSQL, like MongoDB, like
their RAG application needs. And we're taking it further with Azure Databricks, connecting your data in Genie spaces or in AI functions to Foundry. The other very cool capability is now inside of a PostgreSQL query, you can have LLM directly, LLM responses directly integrated. So basically, you can have natural language and SQL mixed together and have the orchestration happen and a query plan happen in a very different way. And it's sort of when it comes to Fabric, which we launched here at Build 2 years ago, it's at the heart of our data and analytics stack. And Fabric brings together all your data, all your workloads together into this one unified experience. Last fall, we put SQL into Fabric, and today we're taking the next big step. We're bringing Cosmos DB to Fabric too, right? Because AI apps need more than just structured data. They need semi-structured data, whether it's text, images, audio. And with Cosmos and Fabric and your data instantly available alongside SQL, you can now unify your entire data estate and make it ready for AI. And there's a lot more. In fact, we're even building our digital twin builder right into Fabric. Now you can very easily take digital twins with no code, low code. As you can see here, you can map the data from your physical assets.
This is like competing with NVIDIA.
Fast. We're also announcing, shortcut transformations in OneLake. You can think of this as AI-driven ETL. You can apply all these pre-built AI-powered transformations, audio to text or sentiment analysis when data is coming in, summarization, all powered by Foundry straight into Fabric, and all with just a few clicks. Lastly, I want to talk about one of my favorite features now, which is coming to Power BI, which is Copilot in Power BI. So that allows you to chat with all of your data. You can ask questions about data, visually explore, analyze it across multiple Power BI reports and semantic models. It'll also be available. This agent will be available in Microsoft 365 Copilot.
Was my job.
So the power of all the work you did, right? Building out those semantic models, building out those dashboards in Power BI, and now being able to put reasoning models on top of it in a chat interface. I mean, think about sort of what a game changer that will be. And so we're very, very excited about that.
But Power BI's, Power BI's had some like AI stuff in
the bottom layer of the stack, which is infrastructure. As a developer, you face that classic optimization problem between delivering the best AI experience in terms of performance and latency, and then, of course, you got to deliver it with sort of monotonically decreasing cost. And that's why we're taking a systems approach working across the entire industry to optimize the full stack, right? Whether it's the data center, silicon, the system software, or the app server, bringing it all together as one system and optimizing and using the power of software. And our aim is to offer the lowest cost, highest scale infrastructure to build both cloud and next generation of AI workloads. And it all comes down to delivering the most tokens per watt per dollar. And that's sort of the ultimate equation for us.
Interesting.
And we're riding multiple S-curves, right, across silicon. Think of it as classic Moore's law plus system software optimization and the model optimization. It's the compounding effects of those three S-curves.
Look at that GPU efficiency.
And we're doing all of this with real speed, right? So when anything gets ready, you want to bring it into the fleet. In fact, Azure is the first cloud to bring NVIDIA GB200s online and do so at scale. Now, Azure now leads the performance from a single GB200 with NVLink 72 rack, generating as an astonishing number of tokens, right? 865,000 tokens per second. It's the highest throughput for any cloud platform. And of course, there's nobody better to talk about this than Jensen Huang. Let's roll the video.
Hey, bro, we got all the fucking...
Thank you so much, Jensen, for joining yet again for our Build Developer Conference. At the end of the day, our joint goal is to be able to
Jensen
deliver more intelligence to the world. In some sense, you can even say it's tokens per dollar per watt. And so I just wanted to be able to maybe get your perspective on all this, maybe starting, in fact, with the very start of what has been our industry, which is Moore's Law.
So excited to be here, Satya. In fact, 2 years ago, we had just launched the largest AI supercomputer in the world together on Azure. This is the big change in how computing works now. With our new CUDA algorithms and new model technology in your new AI infrastructure on Azure, together, all of that together, 40x speed up over Hopper. That's just an insane speed up in just 2 years.
Oh, shit.
You want to talk about the compounding effects of software that then add to all of what we're doing together?
We still want architecture compatibility. We want the rich ecosystem to be stable so that software developers' investments and all of the AI developers' investments and all your infrastructure customers' investments get to be distributed and amortized across the entire fleet.
You want to speak a little bit to what happens to utilization and the diversity of workloads that get all accelerated?
One of the benefits of CUDA is that the install base is so large. Another benefit of CUDA is that, on the one hand, it's an accelerator architecture. On the other hand, it's fairly general purpose for some of the heaviest workloads. Our two teams are working on accelerating data processing by 20x, 50x, transcoding video, image processing, models of all kinds. All of those different types of algorithms map wonderfully on top of CUDA. Our job is to make sure that that fleet and that workload, all of the workloads of your data center are fully accelerated. The fleet is fully utilized for the entire life of the fleet.
It's not just tokens, but it's all workloads per dollar per watt. Can we really accelerate them all as we continue to innovate across both the hardware and the software boundaries?
And Satya, thank you for your partnership and leadership and the alignment between our two organizations to build the most advanced infrastructure in the world, the most advanced AI factories in the world, and the best of times are yet to come.
Thank you, Jensen.
Jumped around that.
So in fact, the largest GB200-based supercomputer is going to be Azure. And so we're very, very excited about scaling this and making it available to all of you as developers. In fact, we are continuing to expand Azure. We now have 70+ data center regions, more than any other provider. Over the past 3 months alone, we have opened 10 data centers across countries and continents. And of course, We're building a complete AI system. That means it includes cooling to meet the demands of AI workloads. With Maya, we had introduced and engineered this Sidekick liquid cooling unit that also supports now GB200 in this closed fashion, such that, closed loop fashion, so that you can really consume zero water. On the network side, our newest data centers built for AI have more fiber optics than we added in all of Azure before last year. I mean, think about that, right?
That's crazy.
It's just even the data center design is just mind-blowing for me when I go back and see them. It's unlike anything that at least I grew up with. We're connecting our DCs with this AI WAN, 400 terabyte backbone. So think about
Microsoft has struggled
all the type of workloads, right? Whether it's inference or training needs, when you distribute them, the AI WAN connects this data center footprint. And of course, the AI applications themselves, right? It's not just about having an AI accelerator or a GPU. You need all of your compute. And every app needs storage and compute. And that's also a place where we are driving a lot of the S-curve efficiency there as well. Last October, we launched Cobalt, our ARM-based VMs. They're already powering a lot of our own workloads with massive scale. Teams runs on it, Defender runs on it. We have all our partners, Adobe, Databricks, Snowflake, all sort of scaling on Cobalt.
All cloud providers now are kind of working on an ARM CPU.
Workloads that are running on using
AWS
sort
has
of a
Graviton.
fungible fleet of AI accelerators and GPU and
Google, actually.
Compute and storage.
They have the TPU.
Meta Office is an unbelievable example, right? They're using Azure to better predict the weather, ensuring timely and accurate forecasting for millions. The supercomputer they built on Azure is the most advanced supercomputer of any kind for weather and climate science. Let's take a look.
Google's also, DeepMind is working on weather prediction. We actually covered it on stream a few months ago.
Has been in existence for over 170 years, delivering the most trusted weather and climate intelligence in our radically changing world. Every day, we are taking on board more than 50 billion observations, 200, 300 terabytes of operational data a day. So we need very big storage and very big compute to be able to do that numerical weather prediction.
So the resolution of model is very important. They require a lot of supercomputing power. The more supercomputing power we have will help increase the accuracy of our forecasts. So that will also then help people make better decisions.
The weather and climate science is big science. The data that those models produce underpins all our products and services.
Our ability to repeatably and reliably deliver these massive supercomputing services is of paramount importance, and we can only really do that in something like Azure. This program really puts a scientific supercomputer in the heart of the Azure wider infrastructure, and it's fully integrated, which means that as we go forwards, we can start to develop new and currently impossible products and services.
It's going to be the world's first cloud-based, solely for weather forecasting supercomputer.
It enables us to run more complicated models at higher resolution to provide more timely and accurate predictions. And our customers will notice improvements to our forecast accuracy.
Good morning. Welcome to our UK Met Office weather update.
We do weather forecasts and climate predictions for the public, for the government and for businesses. It's about that honesty and about building that trust so that when the weather is severe, people do believe what you're going to say, and most importantly, they act upon it.
Looking further ahead, we've got really exciting plans where we're extending our forecast range, higher resolution modeling, all of which will benefit our weather forecast accuracy, timeliness and usefulness.
It's just going to enhance everything that we do here at the Met Office and improve everyone's lives.
You know, it's, of course, more than just performance and efficiency. It's about digital resilience. We have the most comprehensive set of compliance capabilities in the cloud. We offer sovereign controls such as data residency, confidential computing for cloud infrastructure, including your AI accelerators and GPUs, as well as the PaaS workloads. This ensures that you maintain that complete control and how your systems are governed, who has access to them. Now, while our cloud offers this comprehensive coverage, there are still many critical use cases that need extreme low latency and explicit control where and how your apps and data are stored. And that means the ability to run things disconnected. And that's why we also offer Azure Local. Now, so far, we've talked about developer and knowledge worker workflows on our AI platform. But there's one more domain that I want to talk about to close out, which is science. One of the most exciting things, I think, that'll happen over the years to come is we'll have real breakthroughs in the scientific process itself, which will really accelerate our ability to create a new material, a new compound, a new molecule. And that's why we're bringing together the entire stack I talked about today and saying, look, let's apply it to science and the scientific workflow, the scientific process. That's our ambition with Microsoft Discovery, which we are announcing today. Microsoft, if you sort of think about GitHub for software developers, Microsoft 365, and Copilot and Copilot Studio for knowledge work and business process, Microsoft Discovery is for science, right? It's built on a very powerful graph-based knowledge engine, GraphRag. And instead of just merely retrieving facts, I mean, this is the key thing. It understands the nuanced knowledge in the scientific domain, right, from public domain as well as your own data if you're a biopharma company. Discovery is built on Foundry, bringing advanced agents, highly specialized in R&D, not just for reasoning, but for conducting research itself.
I wonder how much Microsoft's been involved in
static pipelines,
more like traditional science space before this. I don't actually know, but I'm curious if they're breaking into it or if this is like they're increasing their offerings.
I mean, think about like that Copilot agent or coding agent. This is the science agent. Let me hand it over to John to show you all this in action. John?
Like, I wonder why they ended on this too. Like, it's kind of...
Thanks, Satya. I'm John, chemistry product lead for our science platform. Today, I'll show you how I lead a team of agents to make a discovery for immersion coolants. These are an interesting line of research for cooling data centers. Unfortunately, most of them are based on PFAS, or forever chemicals, which are harmful for the environment. So, how could I discover a better coolant? I'll show you 3 steps today: reasoning over knowledge, generating hypotheses, and running experiments, all in an iterative loop. Let's dive in. My first step is to conduct research. So I want to be up to date with the latest knowledge on this topic. So I'll start by asking about coolants and their properties to help me identify starting candidates.
This is like Microsoft Discovery.
The platform uses a network of agents that reason over scientific knowledge in both public sources and your trusted internal research. Behind the scenes, it uses a knowledge graph to provide deeper insights and more accurate answers than we get from LLMs on their own, which can struggle to connect the dots.
Actually,
this process will take a few minutes, so let's skip ahead. And what we see here is a summary on the left and a comprehensive report on the right, covering the state-of-the-art in coolant research, with links throughout to citations for trusted research. Now, I can validate these findings and iterate if I choose before moving on, but our goal today is not just to reason over knowledge. We want to make a real coolant discovery. So we need to move on to step 2, which is generating hypotheses. So I am going to ask for a plan specific to my investigation, informed by this research, knowing, for example, that I should target a specific boiling point and a dielectric constant that won't fry my electronics. So we'll submit that. Now, my team of agents is working to build the right workflow. Now, you'll see I didn't specify what methods to use or write any code. Microsoft Discovery handles it all for me. The agents can use tools and models from Microsoft. They can integrate open source or third-party solutions, or even ones from my own organization. And I can always adjust this plan, either adding additional steps or changing the criteria so that I'm always in control. And if we look right here, we can see the plan that my agents returned. It starts with a generative chemistry step here, where it creates millions of novel candidates that are more likely to meet my criteria. And then it uses AI models to screen these down quickly. And finally, we use HPC simulations for validation of our findings. And you know, as I look at this, I like this plan. It looks like a good approach, so let's go ahead and run it. We click proceed right there. And with that, we're in step 3, experimentation. Microsoft Discovery executes this full plan, choosing and managing the best HPC resources in Azure. And in the future, it will also integrate our advances in quantum computing. We can see here now the Discovery agents working together in real time, driving all of these intense computations. With traditional methods, getting to a short list of candidates could take months or years of trial and error. Microsoft Discovery can compress the time to days or even hours. So let me show you the final results of the process. These are the set of candidates that Microsoft Discovery has identified for PFAS-free immersion coolants. So now I can analyze these results to decide if I'm ready to head to the lab or if I need to run another iteration. And if I just take a look at a couple of these, I can see that, indeed, yeah, the boiling points are in line with my expectations, and the dielectric constant is great. So this is very promising.
That's cool.
But I know what you're wondering. Did we actually make a discovery? Well, this is not just a demo. We really did this. We took one of the most promising candidates and synthesized it. They didn't let me bring a new material unknown to humans onto this stage, but I've got this video from the lab. So we can see there my coolant, and we dropped a standard PC in it, and it's running Forza Motorsport. And it is keeping the temperature stable with no fans. It's literally very cool.
That's cool that I actually like tried to make one, make a real material from.
We found a promising candidate for an immersion coolant that does not rely on forever chemicals.
Wow.
Imagine using Microsoft Discovery across domains, designing new therapeutics, new semiconductors, or new materials. It worked for us. The next great breakthrough is yours to discover. Thank you. Have a great build. Back to you, Satya.
Thank you, John. It is indeed very, very cool. It's great to see how companies across every industry are already using Discovery to accelerate their R&D, and I can't wait to see this in the hands of more R&D labs all over and what they can do. So that was, a quick, comprehensive, whatever you want to call it, walk through the full stack and how we're creating new opportunity for you across the agentic web. We're taking really a systems approach, a platform approach, which you can expect from Microsoft across every layer of the stack, right? Whether it's GitHub and GitHub Copilot enabling an open ecosystem for the software development lifecycle, Microsoft 365 Copilot and Teams and Copilot Studio enabling agents for every role and business process. And an agent factory in Foundry, enabling you to build any AI app, any agent, using any data, all running on world-class infrastructure. And all of this on a robust set of rails for management, identity, and security. Ultimately, though, all of this is about creating opportunity to fuel your ambition. I think back to some of the developers I've had the chance to meet over the course of the last year, right? A father in Spain using Foundry to help speed diagnosis of rare diseases like the one affecting his son, a startup in South America building an app to gamify wellness, an airline in Japan using Phi to help flight attendants complete reports even when they're 30,000 feet above. Examples like this is what I'm excited about and take much pride in. After all, the big winners are going to be people like yourselves who are going to build these applications, not just people who create platforms like us. The winners need to be across every sector of the economy in every part of the world. That's our goal. For us, it's never been about the technology. It's about what people can do with it. And that's what is core to our mission. And I want to leave you with this one real powerful example. You know, earlier this year, World Bank conducted a study for students in Nigeria using Copilot. What they found was pretty remarkable. By their analysis, it was the best, most effective educational intervention involving tech. I mean, this is something I've been working throughout my life at Microsoft.
There's been a lot of news around AI and education
and to
lately.
see finally, in a country like Nigeria, putting something in the hands of people and having it really register, you know, statistically as an intervention that had positive impact. The World Bank has expanded the program to Peru, where hundreds of public school teachers are now using Copilot to enhance lesson plans, improve student outcomes, and grow in their own careers. So let's roll the video. Thank you all very, very much. Enjoy the rest of Build.
All right. We'll watch this here, and then we'll...
En Lima Metropolitana, los niños que corren el riesgo de no recibir una educación de calidad se aproxima a un poco más de 445.000 estudiantes.
Los docentes se enfrentan a una realidad muy heterogénea dentro del aula y tienen que pensar cómo lograr que todos los estudiantes aprendan, aun cuando estén a niveles muy distintos. El Banco Mundial está trabajando activamente para mejorar la educación y en colaboración con la Dirección Regional de Lima decidimos capacitar a los docentes en el uso de la inteligencia artificial porque la IA tiene el potencial de transformar la educación.
Microsoft 365 Copilot Chat se ha destinado a más de 390 escuelas en Lima Metropolitana, a más de 482 docentes para mejorar los aprendizajes en el aula.
Copilot me ayuda a elaborar actividades personalizadas para mis niños neurodivergentes, sin ser mi especialidad. De tal forma que ellos ahora se sienten integrados, lo que antes no pasaba. Eso es para mí fenomenal. Yo estoy feliz.
La inteligencia artificial me generaba temor. Mi opinión es que era una competencia para los docentes y no me creía con la suficiente capacidad de poder manejar este tipo de herramientas. Pero a través de esta formación que hemos tenido, Copilot me está haciendo sentir una docente empoderada. Me propone estrategias muy creativas y personalizadas para cada uno de ellos. Por ende, los estudiantes van mejorando su aprendizaje. Eso me hace sentir satisfecha. Ahora puedo darle más a mis estudiantes.
Hello and welcome to Microsoft Build, but backstage.
All right. That was 2 hours Microsoft Build. Pretty much there was cool stuff. I'm gonna have to digest it afterwards. I'll probably make a video this Friday going through all the keynotes, because tomorrow we got Google I/O, Sundar Pichai keynote. Last night 8 p.m. we had Microsoft, NVIDIA, or we had Jensen Huang, NVIDIA CEO's keynote at Computex, and then now we just got Satya Nadella with Microsoft Build. A lot of big tech happenings this week, but I think really it's the platform, you know, like Azure, Microsoft pushing Azure, all of the stuff integrated within Azure because they want everyone on their own platform. And then I thought there'd be much more Windows news, but there really wasn't much on Windows. The Windows MCP server is really cool. I hope you could do more outside of Copilot with it. But the platform, that's what I'm saying, like, because Microsoft wants, you know, with like Windows, arguably like Xbox, they don't have a mobile platform, I guess. They have it with laptops, but Microsoft really wants the platform, just like Apple has, you know, the App Store in like iOS and Mac as platforms. Microsoft is trying to do that now for like AI. It seems like specifically agents right now. They want platforms are very easy because it's like you're kind of a middleman. You just offer some tools and then you kind of just take a cut of it. That's kind of what I got out of what they really want to do. They want to lock you in to the platform so that they could kind of, get you in and then start making money from there. And we're going to watch NVIDIA next, and NVIDIA's doing exactly the same, just in a different layer. NVIDIA's doing it for the data center what Microsoft is doing for software. We're likely going to see the same with Google in the future, or, Google tomorrow, where Google's closer to Microsoft, but they're going to want you in their platform. We're going to see like Gemini Studio, Google Cloud, GCP stuff. Like they're going to want you all in their little ecosystem there. Microsoft is definitely more enterprisey though. Like they're definitely targeting more like business to business, like Fortune 500 type of companies. Not a lot of like retail devs, like local dev stuff. Copilot stuff is, but Microsoft is very enterprisey. I think tomorrow Google will probably see a bit more like consumer technology, like consumer facing stuff. At least I hope. But yeah, that was a lot to unpack. I'm just gonna roll right into NVIDIA's Computex keynote. We're gonna watch the highlights here. Got 20 minutes. Theirs is again like it's a little enterprisey. It's a little dense just because a lot of it is like it's very jargon heavy. Sometimes it's like stuff is going over my head. I was like, can you just say it in like plain English, please? Yeah, let's watch this. Oh my goodness. I watched some of this last night. The first half was pretty much like the meat of it. There was rumors that NVIDIA would be launching a CPU, but that hasn't come through yet. There's been a lot of, I'm seeing this like right here, although Gamer Nexus is kind of negative in my opinion. A lot of the consumer tech bros, Gamers Nexus, Paul, I can't remember his name. They're kind of butthurt about the specs of some of the stuff they launched, I guess. So we'll see that. But the only thing is that Jensen is definitely regurgitating the same thing from all of their kind of his keynotes he's had this year, just in like a different context. Like it's all about creating AI factories. It's about, the data center and like, the entire stack of the data center. They really want you to be using AI as AI and AI agents as a replacement for more traditional software. Like that's kind of like the new like layer is like, oh, instead of writing software or like so to do the thing, you could just ask AI and then it kind of just like figures it out and like goes and does it. The AI factories, we saw that in Microsoft Build with Satya Nadella, kind of like that whole spiel. I will say that Jensen's like he's trying to sell it, so like that he is incentivized to kind of push this stuff. And so I think that's kind of where it's like you got to take it at face value, wait for things to actually roll out and like the stuff to actually come to fruition more. But anyways, the last key point I think that is important is that this is in Taiwan. They are large geopolitical tensions, not only between Taiwan and China, but just United States and China, and arguably even most of the world in China, especially with AI. I'm my OpenAI for countries. I talk a lot about kind of the China's play, China's place in the AI race. It's a video on my channel. You should go watch it if you don't, if you haven't seen it. This is in Taiwan, and so NVIDIA's had a pretty tumultuous relationship with China recently, thanks in part due to the Trump administration, but also just NVIDIA still sells to the entire world. With GPUs being a very tight commodity right now, NVIDIA is just very much in the spotlight, and I almost feel like this Computex happening in Taiwan is in like all of the American big tech companies going in, like consumer technology companies and just big tech companies going there to kind of show things off right, a few miles from China. Like it seems very, like they're thinking of that, I guess, is a point. And I'm pretty sure Jensen is from Taiwan, if I'm not mistaken, too. So I think that's also interesting. Yeah, let's watch this, and we'll just commentate as it goes on. Also, I love Jensen wearing the leather jacket instead of the suit. Very refreshing. He feels alive. All right. I feel like when he wears the suit, it constricts him. All right. Also, when he wears a suit, he's definitely
one of the most important
in the politicking mood. So the fact that he's wearing a leather jacket is he's in chill mode. All right. He's in keynote mode. Anyways,
industries, of course, is telecommunications. Just as the world's cloud data centers have now become software defined, it stands to reason.
Sorry, let me actually make it so you can see everything. Good enough.
That telecommunication should also be software defined. And so that's the reason why we've taken now some 6 years to refine and optimize a fully accelerated radio access network RAN stack that does incredible performance.
We've actually looked at the NVIDIA telecommunications stuff on stream here back when they announced it, like a little like earlier this year, end of last year. NVIDIA's trying to get the full stack of communications for like internet, data centers. Telecommunications is kind of interesting because who is outside of NVIDIA, who is one of the largest telecommunications maker in the world? Huawei, biggest Chinese company. But Trump has banned them. Trump has said to the world to not use any of Huawei's equipment. And Huawei recently released a GPU to directly compete with NVIDIA. I think this is kind of interesting how NVIDIA is now getting more into the telecommunications space than they already are. They've been in there, and now they're bringing AI into it, which is kind of but
for data
also,
rate
we're gonna
per megawatt or data rate per watt, we are now on par with the state-of-the-art ASICs. And so once we could do that, once we could achieve that level of performance and functionality, then after that we can layer on top AI. And so we have great partners here. You can see SoftBank and T-Mobile, Indosat and Vodafone are doing trials. Nokia, Samsung, Kyocera are working with us on the full stack. Fujitsu and Cisco are working on the systems. And so now we have the ability to introduce the idea of AI on 5G or AI on 6G along with AI on computing. We're doing that with quantum computing. Quantum computing is still at the noisy intermediate scale quantum, called NISQ. However, there are many, many good applications we could already start to do. And so we're excited about that. We're working on a quantum classical or quantum GPU computing platform. We call it CUDA-Q, working with amazing companies around the world.
A lot of this was about CUDA too. There's a very long portion about CUDA. I don't know if we'll talk about it, but they're Jensen even talked about CUDA with Satya Nadella just before this, because CUDA is kind of the underlying of it's a software layer on NVIDIA's infrastructure, and that's kind of besides the actual performance, that's one of NVIDIA's biggest differentiator and competitive advantage compared to the likes of like AMD, which is there's really not many other competitors, I guess, but like AMD, likely even the Chinese competitors. But software, the CUDA is that's how NVIDIA has been as successful as they have, in my opinion. One of their big reasons.
GPUs could be used for pre-processing and post-processing, for error correction, for control.
Quantum computing.
So in the future.
Okay, then the last thing, and I sort of will let this play out. NVIDIA's just been they've managed to ride every emerging technology wave since like the 2000s. Kind of in the 2000s, they started out with gaming, which at the time was an emerging technology. They kind of transitioned into cloud computing. which rode out for a while. And then arguably gaming kind of had another surge. And then we had cryptocurrency. NVIDIA rode the crypto wave. And now they're riding the AI wave after crypto for with artificial intelligence. But it's just the next emerging technology that they've somehow again managed to benefit one of the biggest beneficiaries from AI. And now if they get into quantum computing, it's like they're literally hitting every single emerging technology wave. You could also say the same with like Google and even Microsoft, because they've kind of been alongside NVIDIA, mainly Google, but Google's been later because they bought DeepMind, I guess. So anyways, NVIDIA just rode every single emerging technology wave, so it's crazy that they're likely going to hit the next of quantum computing. At least at Jensen, if I was Jensen, I would be wanting that, because quantum computing could potentially replace the more traditional computing, quote unquote, with what NVIDIA produces now. So it's like they gotta kind of be on this. Anyways, yeah.
I predict that all supercomputers will have quantum accelerators, all have quantum QPUs connected to it. And so a supercomputer would be a QPU with QPUs and GPUs and some CPUs. And that would be the representation of a modern computer.
But of course he's going to say that. I'm just saying, like, he's definitely going to say that because he wants GPUs to likely still be part of it.
In the last several years, we've been working on a new computer to make it possible for us to do inference time scaling, or basically thinking incredibly fast. Because when you think, you're generating a lot of tokens in your head, if you will. You're generating a lot of thoughts, and you iterate in your brain before you produce the answer. Totally. So what used to be one-shot AI is now going to be thinking AI, reasoning AI, inference time scaling AI. And that's going to take a lot more computation. And so we created a new system called Grace Blackwell. Grace Blackwell does several things. It has the ability to scale up. Scale up means to turn what is a computer into a giant computer. Scale out is to take a computer and connect many of them together and let the work be done in many different computers. Scaling out is easy. Scaling up is incredibly hard. Building larger computers that is beyond the limits of semiconductor physics is insanely hard. And that's what Grace Blackwell does. Grace Blackwell broke just about everything. And all of you in the audience, many of you are partnering with us to build Grace Blackwell systems. I'm so happy to say that we're in full production, but we can also say it was incredibly challenging. Yeah. Although the Blackwell systems based on HGX has been in full production since the end of last year and has been available since February, we are now just putting online all the Grace Blackwell systems. They're coming online all over the place every single day.
Yeah.
It's available in CoreWeave now for several weeks. It's already being used by many CSPs. And now you're starting to see it coming up from everywhere. Everybody's starting to tweet out that Grace Blackwell is in full production. In Q3 of this year, just as I promised, every single year, we will increase the performance of our platform every single year like rhythm. And this year, in Q3, we'll upgrade to Grace Blackwell GB300. The GB300 will increase the...
It's crazy because he literally is talking about just rolling out the previous generation, and he's already talking about the next one. Like, bro, if I was companies, I'd be like, guys, like, bro, you just spent how much money buying these new ones, and then there's already a new one? Like, Jesus. But I guess that's how they make their money, you know? And arguably, you do want, like, as a business, or like as a Microsoft or a Google or an OpenAI, like, you do want continually faster chips. But it's like, there has to be some fatigue, I would think, you know, like in terms of like money. Like we looked at CoreWeave. He just mentioned CoreWeave. CoreWeave is a public company now. They IPO'd maybe a month or so ago, but they have to borrow money against their own GPUs to buy more GPUs. If NVIDIA is launching them this quickly and customers expect the newest, fastest, most powerful GPUs, like the new GB300 or whatever he's going to launch this year after they just said rolling out the other ones is good. Like, CoreWeave is like, they're not going to be able to keep up. They're gonna go out because they can't keep borrowing money against depreciating assets. Like, that's going to be a problem. But it's crazy the cadence that NVIDIA is going on now. I wonder how businesses actually feel about that, like their customers.
The same architecture, same physical footprint, same electrical and mechanicals, but the chips inside have been upgraded. It has upgraded with a new Blackwell chip. It's now 1.5 times more inference performance. has 1.5 times more HBM memory, and it has 2 times more networking. And so the overall system performance is higher.
That's like
all of that is so that we could
2x overall. Like that's like pretty good, I guess. I don't know what pricing would be.
Build a very large chip. And NVLink and Blackwell, this generation, made it possible for us to create these incredible systems. Here's one from Pegatron and QCT and Wistron and WeWin. This is from Foxconn and Gigabyte and ASUS. And you can see the front and the back of it. And its entire goal is to take these Blackwell chips that are, you could see how big they are, and turn it into one massive chip. Now, the ability to do that, of course, was made possible by NVLink. But it understates the complexity of the system architecture, the rich software ecosystem that connects it all together, the entire ecosystem of 150 companies that came together to build this. This architecture and the entire ecosystem in technology, in software, in industry has been the work of 3 years. This is a massive industrial investment.
Yeah, I mean, he's not wrong.
Now, we would like to make it possible
yeah.
for anybody who wants to build data centers. It could be a whole bunch of NVIDIA GB200s or 300s and accelerated computing systems from NVIDIA. It could be somebody else. And so today, we're announcing something very special. We're announcing NVIDIA NVLink Fusion. NVLink Fusion is so that you can build semi-custom AI infrastructure.
You could
not just semi-custom chips.
Use different GPUs
because those are the good old days.
Mix and match.
You want to build AI infrastructure.
Mix and
everybody's
hardware.
AI infrastructure could be a little different. Some of you could have a lot more CPUs, and some of it could have a lot more NVIDIA GPUs, and some of it could be somebody's semi-custom ASICs. And those systems are so insanely hard to build. And they're all missing this one incredible ingredient. This incredible ingredient called NVLink. NVLink so that you could scale up these semi-custom systems and build really powerful computers. And so today we're announcing the NVLink Fusion. NVLink Fusion kind of works like this. This is the NVIDIA platform, 100% NVIDIA. You got NVIDIA CPU, NVIDIA GPU, the NVLink switches.
This is what they want.
Networking from NVIDIA called Spectrum X or InfiniBand, NICs, network interconnects, switches, and all of the entire system, the entire infrastructure built end-to-end. Now, of course, you can mix and match it if you like. And we now today make it possible for you to mix and match it even at the compute level. This would be what you would do using your custom ASIC. And we have great partners I'll announce in a second.
This is interesting because what I see NVIDIA doing is there are existing data center customers who likely can't purchase certain NVIDIA equipment due to compatibility issues with existing hardware or existing partnerships. NVIDIA now offering non-NVIDIA compute that could now be like connect to the existing infrastructure of NVIDIA. This seems like they're potentially expanding their offerings to other customers who might not necessarily just be able to like buy full stack NVIDIA, like with Grace Blackwell's, their newest GPUs. Could be a wrong interpretation, but I think NVIDIA being now pushed out of China, they're going to have to expand and continue to, like, if they want to continue to grow, going to have to go into new markets and new channels. This might look like something that could, help them make up, business otherwise and also sell to just more people. This is also, I think, if we want to talk about like the American AI or democratic AI, which OpenAI for countries is kind of like pushing, and we want like American infrastructure in other countries when it comes to AI, so we could kind of own the stack, or at least America could have some influence on, the geopolitics of AI. This could be another pathway for us to get more American, quote unquote, AI infrastructure in other countries. Now there might, I feel like, who
are working with us.
I think there was a rumor that NVIDIA is also now moving to Taiwan as their headquarters so they could get around American sanctions on things like China's import or Trump's administration's import restrictions on China for chips. But We'll look into that after this. Anyways, I feel like that's still all kind of interconnected, and NVIDIA offering this is kind of could be aligned with that.
To integrate your special TPU or your special ASIC, your special accelerator. And it doesn't have to be just a transformer accelerator. It could be an accelerator of any kind that you would like to integrate into a large scale-up system. We create an NVLink chiplet. It's basically a switch that abuts right up to your chip. There's IP that will be available to integrate into your semi-custom ASIC. And then once you do that, it fits right into the compute boards that I mentioned, and it fits into this ecosystem of an AI supercomputer that I've shown you. Now, maybe what you would like is you would like to use your own CPU. You've been building your own CPU for some time, and maybe your CPU has built a very large ecosystem, and you would like to integrate NVIDIA into your ecosystem. And now we make it possible for you to do that. You could do that by building your custom CPU. We provide you with our NVLink chip-to-chip interface into your ASIC. We connect it with NVLink chiplets, and now it connects and directly abuts into the Blackwell chips.
Okay, so maybe I'm misinterpreting this in a different way, but it also seems like they're offering this at like the chip level. So like if you are building like a ASIC, like a compute for like to solve a specific problem, which, you know, ASIC is I don't remember what the acronym is, but it's like it's a compute. Let's just look it up real quick, since I'm not. Can't remember what it stands for. Application specific, yeah, integrate circuit. But it's for a specific problem. It seems like NVIDIA's offering their like chip, or you know, their designs on the chip. That's where NVLink is going into play.
And our next generation Rubin chips. And again, it fits right into this ecosystem. DGX Spark.
All right. Okay, DGX Spark too. Like they announced this. Jensen announced this like a month or two ago, or a few months ago. The most interesting thing from it is that they're using a custom CPU that NVIDIA's made in partnership with Foxconn, I think they said. That's the most interesting part, but otherwise, I don't know who they're targeting because it's still hell expensive.
We'll be ready. We'll be available shortly, probably in a few weeks. We have tremendous partners working with us: Dell, HPI, ASUS, MSI, Gigabyte, Lenovo. Incredible partners working with us. And this is the DGX Spark. This is actually a production unit. This is our version. However, our partners are building a whole bunch of different versions.
Okay.
This is designed for AI native developers.
Hopefully it's cheaper.
If you're a developer,
than the partner ones.
you're a student, you're
like
a researcher,
$3,000.
and you don't want to keep opening up the cloud and getting it prepared, and then when you're done scrubbing it, okay? But you would just like to have your own, basically your own AI cloud sitting right next to you, and it's always on, always waiting for you. It allows you to do your prototyping, early development, and this is what's amazing. This is DGX Spark. It's 1 petaflops and 128 gigabytes. In 2016, when I delivered DGX1, this is just the bezel. I can't lift the whole computer. It's 300 pounds. This is DGX1. This is 1 petaflops and 128 gigabytes. Of course, this is 128 gigabytes of HBM memory, and this is 128 gigabytes of LPDDR5X. The performance is, in fact, quite similar. But what's most important is that the work that you could work on this is the same work you could do here. It's an incredible achievement over just the course of about 10 years. Okay, so this is DGX Spark for anybody who would like to have their own AI supercomputer. And it's, I'll let all of our partners price it for themselves, but one thing for sure,
he doesn't even say the price.
Everybody can have one for Christmas.
Bro, it's like, they were expensive though. They were pretty expensive. Like I last time around, they were $3,000. I hope the partner ones are much more reasonable.
This is another desk side.
And so that's why it's like, at that point, you might as well just buy a 5,000, like a 5090. Like, is no way a 5090 is less powerful than that thing.
This is also going to be available from Dell and HPI, ASUS, Gigabyte, MSI, Lenovo. It'll be available from Box, from Lambda, amazing workstation companies. And this is going to be your own personal DGX supercomputer. This computer is the most performance you can possibly get out of a wall socket. You could put this in your
800
kitchen.
gigabytes of unified system memory. That's crazy.
But just barely. If you put this in your kitchen and then somebody runs the microwave, I think that's the limit. And so this is the limit.
Yeah, bro. Like that is insane that like this thing draws so much power. They're likely getting to the peak of what residential, power could actually handle. Like what at least in America, I want to say like most like breakers are like 250 kilowatts, which is like like 25,000 watts. Like for example, my desktop computer right now is pushing at like 1,000 watts. Like, like when I'm, using a lot, couple on top of oven, microwave, washer, dryer, like, you maybe like I have a, server, I have other like computers running in the house. Like then you pull this thing, which this thing is pulling probably a few thousand watts. Like we're getting there.
This is the limit of what you can get out of a wall outlet. This is a DGX.
He just said it's a limit we could have of the wall outlet. Because I think a wall outlet's like 120 volts too. And you're like, you need to get like a dryer 240 volt like outlet put in just to run, like this like computer, like that'd be crazy. But this is also just a bigger trend of like America's power grid, like we're getting there, we're getting to the capacity.
Station. The programming model of this and the giant systems that I showed you are the same. That's the amazing thing. One architecture, and this has the ability, enough capacity and performance to run a 1 trillion parameter AI model. Remember, Llama is Llama 70B. A 1 trillion parameter model is going to run wonderfully on this machine.
Dang.
Okay, so that's the DGX station.
You could run I wonder if you could run a Llama Behemoth on here.
This is the brand new.
I wonder how much it's going to cost though. I want to like email them and just like see like, hey, I'm like a content creator. Can I get one?
Pro, RTX Pro, Enterprise, and Omniverse server. This server can run everything. It has x86, of course. It can run all of the classical hypervisors. It runs Kubernetes in those hypervisors. So the way that your IT department wants to manage your network and how they want to manage your clusters and orchestrate workload works exactly the same way. It has the ability to even stream Citrix and what other virtual desktops to your PC. Everything that runs in the world today should run here. Omniverse runs on here perfectly. But in addition to that, this is the computer for enterprise AI agents. Those AI agents could be only text. Those AI agents could also be computer graphics. Little TJs, coming to you, little toy Jensen's coming to see you, helping you do work. And so those AI agents could be either in text form, it could be in graphics form, it could be in video form. All of those workloads work on this system. No matter the modality, every single model that we know of in the world, every application that we know of should run on this. In fact, even Crysis works on here. Okay, so anybody who's a GeForce gamer?
Yeah, that's like a meme.
There's no GeForce gamer in the room.
Bro, what? That's funny. That's deep cut, Jensen, all right? To your gamers watching out there, that was a reference.
So in order for
he could have made a Skyrim joke too.
Robotics to happen, you need AI. But in order to teach the AI, you need AI. And so this is really the great thing about the era of agents, where we need a large amount of synthetic data.
And going back to the emerging technologies that I was talking about earlier, robotics is also one of them. That's arguably probably like, that might be the next one after AI, because I still think quantum computing, we have a while, but actually maybe quantum computing it might be the next after AI, and then we get robotics. But regardless, NVIDIA is already positioning themselves to benefit from future the future robotics industry, not even AI and robotics, just robotics in general. The Cosmos, I think, is their robotics platform, and they created a kind of a chip, I guess, that could act as the brain for the robot. But again, it's their software. They created software that you could train robots digitally. With Omniverse, you could create data to then train. NVIDIA software is they're really making all their stuff come together with the software, and I think that's kind of like just a big differentiator. I know I keep saying that, but like it's their moat. It's NVIDIA's moat right now. But yeah, NVIDIA's also going to ride the robotics wave likely too, and make a shit ton of money from that. So, and it's the early days too. Even from from their offerings, they only offer a few things, and as they expand and as robotics get bigger, like NVIDIA's just going to cannibalize that market.
The generation, robotics, a large amount of synthetic data generation, and skill learning called fine tuning, which is a lot of reinforcement learning. An enormous amount of compute.
We still have a while for robotics, in my opinion, though.
This is a whole
especially humanoid robotics. People are like think it's like right around the corner, but like the stuff we're seeing is very primitive, and it's also programmed or it's controlled by a human. Like we have a long time before like robots are just autonomous. Like it's gonna be like we're gonna start with humanoid robotics being programmed with like specific workflows, just like robotic arms are now. We watched how Amazon uses a lot of like random like robots in their factories, but they're all like programmed to do things specifically. We're gonna have to get past that, and that's gonna be what they're gonna be like. Humanoid robots gonna be at first. We got a while, I guess, is my point.
Where the training of these AI, the development of these AI, as well as the running of the AI needs an enormous amount of compute. Well, as I mentioned earlier, the world has a severe shortage of labor. And the reason why humanoid robotics is so important is because it is the only form of robot that can be deployed almost anywhere brownfield. It doesn't have to be greenfield. It could fit into the world we created.
Yep, and that is also that's the benefit and also the detriment of humanoid robotics, in my opinion. Or like the benefit and also the downside is there could be a better way for a robot to navigate the world, but because the world was made by humans, creating a robot like a human is likely just the easiest way for robots to interrupt right off the bat with the world. I think that humanoid form is probably not the most efficient form for robots to be in. And it sucks that we're like going down that route just because we're human and we're just biased towards creating, interacting with the world like a human, I guess. I feel like there could be more novel and better ways for for humanoid robotics. Just robotics in general to navigate.
To do the tasks that we made for ourselves. We engineered the world for ourselves.
Exactly.
And now we could create a robot that fit into that world to help us. Now,
I feel like that's good now, but I think that it could be better.
The amazing thing about human robotics is not just the fact that if it worked, it could be quite versatile. It is likely the only robot that is likely to work. And the reason for that is because technology needs scale. Most of the robotic systems we've had so far are too low volume. And those low volume systems will never achieve the technology scale to get the flywheel going far enough, fast enough, so that we're willing to dedicate enough technology into it to make it better. But humanoid robot, it is likely to be the next multi-trillion-dollar industry. And the technology innovation is incredibly fast. And the consumption of computing and data centers is enormous. But this is one of those applications that needs 3 computers. One computer is an AI for learning. One computer is a simulation engine where the AI can learn how to be a robot in a virtual environment, and then also the deployment of it. Everything that moves.
I'm surprised he only said 3 computers, because Noman Jensen, bro, he could have been like, this robots need at least 15, and you could also buy all 15 from NVIDIA.
Will be robotic. As we put these robots into the factories, remember, the factories are also robotic. Today's factories are so incredibly complex. This is Delta's manufacturing line, and they're getting it ready for a robotic future. It is already robotics and software defined, and now in the future, there'll be robots working in it. In order for us to create robots and design robots that operate as a fleet, as a team, working together in a factory that is also robotic, we have to give it omniverse to learn how to work together. And that digital twin, you now have a digital twin of the robot.
Microsoft would just launch, they talked about a digital twin too, and they, I looked at kind of the text there, and it was definitely specific to logistics or like factories. NVIDIA's digital twin is more, not practical, but it's more what you think about when you see a digital twin, like literally like 3D physical world, not like just flow diagrams, which seem like Microsoft's. So, yeah, I don't know.
You have a digital twin of all of the equipment. You're going to have digital twin of the factory. Those nested digital twins are going to be part of what Omniverse is able to do. This is Delta's digital twin. This is WeWin's digital twin. Now, while you're looking at this, if you look at it too closely, you think that it's in fact photographs. These are all digital twins. They're all simulations. They just look beautiful. The image just looks beautiful, but they're all digital twins. This is Pegatron's digital twin. This is Foxconn's digital twin.
Bro, this is the most this is the most like China factory AI twin ever. Like, but this is what I'm talking about, where it's like, is this the best way? Is this like, you know, this is how like you might be with humans, but like, why do we have to have, you know, like, why do we have to put the robots like this too? You know, like, why do they have to face the front? Like, it's just, I don't know. Also, these robots look like Unitree. These are the Unitree G1 or whatever. 100%, right? Which is interesting, because I wonder if is it public that Foxconn's, like, working with Unitree? These look like that they're robots.
This is Gigabyte's digital twin. This is Quanta's.
Robot arms.
This is Wistron's.
Robot arm.
TSMC is building a digital twin of their next fab. As we speak, there are $5 trillion of plants being planned around the world. Over the next 3 years, $5 trillion of new plants. Because the world is reshaping, because reindustrialization moving around the world, new plants are being built everywhere. This is an enormous opportunity for us to make sure that they build it well and cost effectively and on time. And so putting everything into a digital twin is really a great first step, and preparing it for a robotic future. In fact, building that $5 trillion doesn't include a new type of factory that we're building. And even our own factories, we put in a digital twin. This is the NVIDIA AI factory in a digital twin. Kaohsiung is a digital twin. They made Kaohsiung a digital twin. There are already hundreds of thousands of buildings, millions of miles of roads. And so
this is also interesting because now that if this is like a city making a digital twin, is this like, I wonder if they're using also like a GIS type of software for digital twin too, like a geographical, you know, like I don't know the name, but like I know like ArcGIS, like they usually have like a map of the city, which is kind of like the digital twin, but it's more for geographic stuff. Like, could this replace that?
Yes, Kaohsiung is a digital twin. Not only are we creating the next generation of IT, we are in fact creating a whole new industry. This whole new industry is going to expose us to giant opportunities ahead. I look forward to partnering with all of you on building AI factories, agents for enterprises, robots, all of you amazing partners building the ecosystem with us around one architecture. And so I want to thank all of you for coming today. Have a great Computex, everybody. 大家谢谢.
Thank you. All right, that's NVIDIA, Jensen Huang. Let's actually look at, I have an article, but actually got logged out. 1 second. Let's look at let's look at their stock price. Let's see how they're doing now. Let's see. We got NVIDIA is down. How is CoreWeave up 8%? Probably for announcements. NVIDIA's down. I thought they would be up after what they talked about. Yeah, allegedly bulls. NVIDIA notably also has earnings next week, or in 2 weeks or so. Yeah, next Wednesday, NVIDIA has earnings. So, I mean, that's, we'll see then, but okay, let's look at Microsoft now. Yahoo Finance is so slow. Up. All right. Microsoft, I mean, like, this is like marginal though, but I guess nothing crazy after a Microsoft build is the point. Why is Reddit down 4% today? 4.5%? It's so volatile. Dang. Recent users. All right. They didn't mention the that NVIDIA is building a supercomputer for Taiwan, in partnership with the Taiwanese government, which I think is big because, again, that goes kind of back to my infrastructure argument, where it's like, America really wants to use, we want to be the backbone for AI, for democratic AI in other countries. NVIDIA and Foxconn are partnering with Taiwan to build AI supercomputer. NVIDIA deep in partnership. Yeah. I guess we already kind of saw this, but yeah, it's all very peculiar. And then this was the 16th, but NVIDIA CEO says next chip after H20, and H20 was the China specific chip. Won't be from the Hopper series, which is interesting. He didn't really talk about that yesterday, or in the keynote. And yeah, we also got Stratechery, depending on how you say it. Ben Thompson, who I take a lot of inspiration from. He's kind of an analyst, similar to. I like covering the tech industry kind of like he does, and so this is interesting. I'm gonna read this. I'm not gonna read this on stream, but I would just recommend, if you're interested in more about the chip controls and kind of the geopolitics, I would read this. I'll link it here. But I think that's gonna do it for today's stream. Tomorrow we're just going right off the bat again with Google I/O. Actually, I think the Google I/O conference is at 10 a.m. Pacific, but we're gonna start stream 9 a.m. Pacific, 8:45 around 8:45 to 9 a.m. again. We're gonna continue in the morning before the stream. We're gonna look at other Microsoft build announcements and then other Computex announcements, and then we're gonna roll right into Google I/O with Sundar Pichai, and we're gonna cover it just like we did Microsoft build, and then we'll talk about it afterwards and do some other coverage too. And yeah, we're gonna hang out. So I appreciate everyone hanging out today, tuning in. I really enjoyed the stream. Got a lot of new people today. So yeah, make sure to subscribe on YouTube. The stream for tomorrow is actually already scheduled. So head over to my YouTube channel and you could actually just see the stream right there. We're gonna start around 8:45 and watch Google I/O. So yeah, thanks everyone for tuning in, and we will see you tomorrow 9 a.m. Pacific. I don't have an ending screen. But all right.